Alrighty. First and foremost, been a while. Second thing, the idea is aluminum. It's a little aluminum alloy actually, with magnesium, graphite dust, with silicon. Alright. So apparently, if I do it right, I can make it such that you get one of the hardest substances known to mankind, and a whole bunch of other shit. Talk all about it because I talked all about it yesterday, but I didn't record. I was tired of recording constantly. So, I was like, alright, so I take aluminum, place in some silicon dust in a vacuum chamber. Right? We have magnesium in a graphite dust in a graphite container is what I want to go with. I have graphite dust. There's a plunger. It's argon cooled and it's in a bath, so like all this magnesium is in a chamber that's 3,000. Well, it's not 3,000, but it's pretty high temperature argon. Yeah, just argon. The vacuum is such that it's going to pull this magnesium down into these little plates. But during that, it's going to squeeze them together and then have them only be able to squeeze after they've melted the plate of aluminum and the tube of aluminum that's there. There's some relief areas and so on, but it's like, alright. But like the plunger is actually a hydraulically assisted plunger. Right? So, we're not doing any electricity, we're not doing anything. We're just going to fire it into the aluminum with the silicon, high purity silicon dust, the graphite. Powder being inside the magnesium. Alright, now this argon is at 9 bar in the chamber above. When you screw the little basin, you're going to use this, right, to hold it in, right? It then opens up a valve and allows for you to plunge it down really rapidly and then use that extra pressure to force a lot of this together. Alright? So it's like all of it's going to mix and be forced together. Now I had a very specific way I did it to make a piston head. I'll talk about that later. But then there's a secondary step. It's like there's not going to be any argon in this chamber, but we're going to be IR blasting it. And then we're going to turn off the IR because then we're going to add in the argon. We're going to take out the argon from the below vacuum chamber. We're slowly let it cool. When it's tacky and then it's gooey on the center and then it's hard on the outside, this is when you're going to do this. You're going to start firing in liquid nitrogen. Alright? Creates a bunch of these little shear points that are vertical and horizontal and diagonal and Z diagonals. Alright? Initially. Once it's a little cold, once it's fully submerged in liquid nitrogen, you're going to slowly warm it up, back up to temperature. As it does the total cooling off, instead of the shear little points that are vertical and all that, they do a monkey hand puzzle piece where they wrap in between each other at a molecular level and some covalent bonds that actually do form. It's aluminum, magnesium, and silicon carbide with a little bit of aluminum alloys, whatever that is, with the oxygen that's still going to be a little bit there. Okay? So you'll create a large amount of very insanely high pressure, thanks to it rapidly using thermal shock and cooling, then to fully shrink it down and get it down to a liquid nitrogen level. And then as it expands, it breaks some bonds. You have to slowly warm it up, which means you're going to take that liquid nitrogen and you're going to expose it to a little bit of water. It's cold water, but it's like you're going to slowly get it back to ambient temperature, and then you're going to remove the nitrogen. Nitrogen does nothing to this, as far as I'm concerned. But what I do get is a very hard, dense, light material that's in every way able to handle very high heats and can destroy pretty much all superdiamonds in terms of its function. So, there you go. It's a nice little, that's the material. I've recorded it. Let's see here. I think after I did the rapid cooling until it was liquid nitrogen temperature, which it causes a thermal shock initially, and then once it's under liquid nitrogen, I don't know if I talked about this. Give me a second. Alright, so see here. I made sure to get it up to higher pressure, not just with liquid nitrogen in that vacuum chamber, and submerging it to the point where it was fully, encased in liquid nitrogen. All right, with stuff above it, just regular nitrogen, of course, right? I was like, well, I'm thinking about whether or not it would be a good idea to fully pressurize it back up to that 9 bar. If only just because, that might actually help with the given pressure, thermal pressure in this instance, that is creating. So, I don't think I did that, though. In my, little, mind thing, it does work just fine without it, from what I can understand. Again, you can't, rapidly uncool it. You have to bring it slowly up to temperature and then put it back into a vacuum. You can't, it's atmospheric, but let's put it this way, I have to get it back up to what, is room temperature, but I can't put it back to room temperature without it being under a vacuum. I need it to be under a vacuum to then be able to take it out. So that might be a step that people would miss. But I was talking about it the day before yesterday, because actually, when I started the recording, it was, see here, the 25th, and it is the 26th today. Thursday, October 26th, 2023. So there's that. Pause. I was going to record more. I just never did. But yeah, no, I did that specifically so that way I can create certain chains of interlocking styles of aluminums together with carbons, together with magnesiums, together with silicons that would then break from that thermal shock and the pressure that would be created under an increasingly continual shrink from liquid nitrogen. But I'm like, well, if I do that and then I put it under more pressure, like the 9 bar that I was talking about,
then that would probably end up helping with that whole situation. It's laundry day for me. It's normally on Sunday, but it's a Thursday today. Parents are not going to be around here, so uh, but it's around the time apparently when it's cheap to do laundry. So it's like whatever. So, um, but yeah, no, I was thinking about that to be able to try and make it a little better or a little bit more. Um, for sure, it did that. You know, especially when it's like, well, I'm taking it from whatever that given pressure is back into a point of a vacuum, which means under no atmospheric pressure, which is a bigger deal than you might think, uh, comparatively than what people might expect. Especially when it's a, well, no, I can't just bring it up to temperature rapidly. It has to genuinely take a damn good amount of time in order to do that. That's like a solid 8 hours to like full whole day. It's more of I'm gonna leave it there. I'm gonna slowly exchange it, you know, and get it back up to temperature. Uh, Especially when the liquid nitrogen has to off gas anyways from its given, uh, very cold point, and I don't want the box that I have it in to also crack and die as well, considering like that was its own like, well, I'm gonna, you know, get some sheet steel and some sheet or plate steel or whatever, right? Weld it up a little, put some refractory material in it, put some like heat resistant elements to make IR to allow with the aluminum on the interior a IR reflective to try and IR blast things. Then on top of it, I have some um, induction styles of heating that goes on in that, because it wasn't stupendously difficult to make that. You know, it's really not that insanely difficult to make something like that. That's like high temperature silicone caulking, welding, refractory material, some aluminum, some steel, and the right circuits for the induction and IR electrically resistive heating. Molds are pretty easy to make because most of them you can make from stuff that is easily bought online, like plaster molding. To you can put it in water and get everything uh, you know taken out of the given mold after you push it through the basin. It's a graphite standard basin, but then it's like, all right, well, I'll just get out a lathe or whatever. But it's like it's supposed to mostly get rid of the bottom, but then it's like you have to put in some threads a little bit, but then it's really just like a cone that's at the bottom of it. Yeah, phaser. Yeah, it allows for as you screw it out to then slowly unseat that seal of that, and then it goes off to the sides around it. And then like argon wasn't super difficult because it was like, well, that's a lot. Yeah, you can get argon pretty cheaply, right? But it's like, well, how do I heat it up to like these insanely high temperatures? Is what people would probably go with, and I'm like, that's actually fairly easy. Turns out, it's like get some corrugated steel and put some high temperature ceramic, coating on both sides effectively, and it's a thing where you'll run the argon on one side, and then you'll have like a plasma torch, standard plasma torch, but with like a little Venturi system from that plasma torch as it thermally convects air up, and then you'll recirculate it through with a given higher temperature fan. And so like you'll be able to dynamically balance that given pressure and heat, and then be able to thermally transfer as a heat exchanger into like the other box, which would be another version of the same thing, except with a hole in it, which isn't too difficult. when you have a base in there that seals to the thing, same thing with giving it that kind of pressure, it's actually not too terribly hard. The plunger system is a ceramic puck effectively with like some holes for the so it's a tube within a tube and then a ceramic puck. So like as you push in argon, it'll go from the bottom and then it'll go around the outside tube and so it'll heat up the puck and then it'll go out the top part of the tube that's around that. It just needs to be on for those tubes some pretty high temperature surviving steel, like chromoly or tool steel, you know what I mean? Right? And then it's like, well, you'll go coat it with some decent high temperature surviving ceramic, which you can get at the hardware store. The ceramic puck was another version of like kind of the same thing, where it's like you can get some decent, ceramic and then composite it together um, with a high temperature silicone caulking and like probably graphite paste or whatever, and then it's like form mold it and then let it, sort of like under pressure dry. And under pressure is a good way to describe like the over 10 bar of atmospheric pressure that it was under alongside of clamps for a hydraulic, setup. This is like a mold and some plates of blah blah. You know what I mean? It's effectively like just plate steel, and then there's the mold, and then. Say hello. All right, so let's see here. Right, so the mold would be like steel around that mold, but it's going to make sure that under that with that air pressure that has to be under. So it's like a box that you make, like a sanding box, like sandblasting, a little tiny box, right? But it's like you just need like a small hydraulic ram, kind of thing, and then like a nice little lever to increase like given pressure as you input it with a standard hydraulic assistance, so like electric motor or whatever, to help increase its given potential energy, kind of like they do with cars as a hydraulic assist for steering.
How are you doing?
All right. I don't know where I was. There's a lot of things just happened. I had a lot of conversations after I paused with the yo mom about life. So, let's say this. The basic premise seems nuts to some people, but it's not. It would work. People probably don't understand why I know that, but I've never really had issues with that part. I've just been really good at having that ability to know that it would do something like that, because I know enough about all the individual parts I'm talking about. So it's like the heat exchanging part works. You just probably don't understand why and how. So like I've been truly and Bernoulli, so it's like as it gets squeezed in, it then accelerates and wants to draw other air in. Right? And so like you can use an argon gas to argon gas exchange using that heating type of thing. And the point was to eventually try and get up to a very high temperature around that 300 or 3000 degrees Celsius max. But because it's argon, I don't really have to worry about it. Then that allows for me to add in more and more pressure as a compressor pump that's able to handle higher pressures and temperatures, which you can buy those or you can make them. In this instance, it was simply a already pumped up to that degree of heat. No, interrupt there. Pressure. Pressure is fine. Heat is fine, considering when you don't have to heat it up, you just need to recirculate, which you can have a axle driven pump, which is a tiny little turbo. Sucks in and then pushes it back. All you have to do is allow for it to, ultimately speaking, run through the same style of Venturi-like design principle. So this is a diaphragm that allows for you to, as air is rushed forward, draw in, and then you can push in the hotter argon gas. And the axle type thing here is to lift up using the suck force and then having that axle be there to drive the compressor style. As it gets compressed a little and it sucks in something, you can push in that heat with a vacuum insulation in between two given diaphragms. So it's like vacuum, diaphragm on top, that's doing this work, diaphragm on this part, able to handle the higher heat argon. Simple stuff. You might not understand it very well, but for me, I do, easily. Now you just need enough of an insulation to allow for it to work. One is more than good enough, considering as it compresses and then releases like a spring, as it has the compressed air blow back through it, and then it just needs to go through a heat exchange, which is an intercooler. Simple shit. On the way in to the compression area. So, thought about it. Same thing with the whole valve thing. Totally works. It's actually how they do it in the manufacturing facilities that use a style of high pressure liquid metal mold designs into a vacuum. The vacuum helps suck it in and increase degrees of pressure, and forming into molds with less occlusion and porosity. More uniform structure to the cast. Now, the reason why we have the plunger here with the argon gas is because in the basin, while yes, it will suck it through, it does get a degree of resistance into the given mold. Once you add in the plunger, which just needs to be the right size, with the argon gas itself actually being a part of the O-ring. So like the gas pressure trying to go down into where the basin is, and then it gets hot enough to ultimately form a degree of a seal around it, not being able to go through, then means that you can plunge it with a lever because it was already preheated. Now we're talking 3,000 degrees Celsius. So what it turns into is that ceramic coated chromoly tool steel kind of stuff just needs to be able to handle the heat and pressure that we're at, which gives it a degree of thickness that needs to be accepted. Now we're talking 3,000 degrees Celsius. For some people, they might not understand that the tool steel will handle that so long as it's insulated enough. And you might think that's a small little coating, but that's not what that would be. The ceramic forming around a given plate steel mold with a, kind of like plaster-ish mold, then to gain like those higher heat types, which we absolutely can make at home, turns out, with a composite material, which I'm reluctant to tell you, but like the basic principle is the same. It's honestly often a type of graphite and other averaged out powder coat higher heat ceramics that allows you to, when under pressure and under that heat, form a much stronger, higher heat resistant style of ceramic. And when it's only ever going to be exposed in that heat to argon, it means it doesn't break down as easily or as quickly. Which means I don't have to worry about that. So as the argon rushes in from the sides and then you press on it, it then tries to go around it, then equalize that pressure around the seal area of the plunger puck that we're talking about, kind of like a piston ring. When you have enough of a gap in between, like compression rings, it then means it can't escape as easily. It creates much higher pressures that it has to go through, which is what we use for those given manufacturing designs anyways. If you didn't know that, well, now you do. Which is another reason why it's like, you're probably not well versed, and if you thought it couldn't be done and you're thinking it's insane, I understand where you might come from, but you're just not as knowledgeable as I am or as creative, which is normal. I've met a lot of people like that in my life. Now, the mold that I used for the piston head was an entirely different type of mold that most people would probably be aware of as being worthwhile. Silicon dust wasn't super difficult to figure out. It's like there are microchips, like little, Intel, AMD, CPU stuff, GPU stuff for NVIDIA, whatever. And it's like they're a dime a dozen. Like there's old ass motherfucker, chips that like people don't want anymore, and they'll sell it to you for like a bunch for very little. You know what I mean? And then that one was an easy one because it was like, well, I'll put it into Loctite and I'll blend it in Loctite, like the literal like liquid compound Loctite. It was like I make the blender have a sealed top that sucks out air, and then I place in that the Loctite and make sure it's under the right pressure so it maintains itself as a liquid. And it's just a pump kind of style of things. But then when you blend these chips, which is what we're going to do first and foremost, we then have to take out the Loctite because it's like, well, the Loctite is going to stick to that and we don't really want it. But like the reason why we're going to do that is because Loctite doesn't interact with silicon. It's a low reactive substance. Like it can be under a lot of heat and pressure when you torque it down, and it doesn't react with the metal compounds at all, that kind of thing. So we make some rollers, drum rollers, kind of like what we do for coffee grinding. So once we put it through a filter to filter out the Loctite, which is a liquid compound that would remove it, which they sell that online pretty easily. Then it turns into, we're going to grind it into dust, little fine particles. After we've done that, we then make sure that there's the right static charge differences and electromagnetic charge, field differences under a little bit of heat, which in this instance I didn't really even need, but it was in an argon gas because I have a shit ton of argon. It's easy, it's cheap. So it's like, all right, I'll get that. And then turns out field separation as a type of filter to rip off the given types of golds and whatever else they have on the silicon transistors we're talking about, because it's high purity silicon, right? But they add on metals to make it have a particular type of transistor effect. So it's like we have to separate that, but because now it's really small, we're talking nano-sized to micron-sized dust, because we're going to use heat and the grinding action to grind them down to that size. So it's a roller that then has a perpendicular roller underneath. It's a smaller size, and then another perpendicular below that, and then you run it through again, but at a even smaller size. So you keep doing that until you get the right dust, but you have to do it in a vacuum. So that way it doesn't ultimately get affected by any oxygen. All right. Then you're going to go through the filter separation, which is just a little bit of heat, which truthfully isn't super important. It's really just running it for long enough that you get high purity silicon dust. All right. So like they use heat to more quickly separate things, but when you have time on your hands, you don't need it. Which the static thing creates little arcs through it and it rips off that given element that we're not looking for, along with the electromagnetic field that will help with that process of separation. Then giving it the right type of spin, meaning vortex, like a centrifugal, it also further increases that effect as there are different densities to the given dust flying inside of that chamber. So once you gain back that given dust, you don't really ever want to, ultimately speaking here, remove it from its vacuum, because like you're placing it in a vacuum chamber anyways. So you place it into this. Well, I was doing this for a piston head, right? So, and it was just because it was like, well, aluminum's not going to work. Like that's literally what it was. It was like, well, this is a higher carbon, like plate or whatever of steel, right? It's like just a. I was trying to cast it into a cylinder for then eventually making a aluminum engine block clamp style around the cylinder. Because I wanted to make a single cylinder work really, really well as a concept idea I had. So it was like, well, if I can make a little bit of graphite paste, work for me in that argon chamber, and then I can, spin the basin, right, that I was talking about. And it's like, well, I don't really necessarily need to worry about it. It's like, well, it's in a vacuum down there for the mold I'm going to use for this cylinder and everything, right? It's like, that's easy. But I'm going to preheat it, and then I'll keep it hot with the IR and the, induction, right, together. But it's like, well, the argon is going to be hot, really hot. And it's going to maintain its heat inside of that basin. But like, I initially seal it, right? And then I want to have that graphite kind of, mix with that steel, right? So it's like, well, I'll spin it and I'll put in the plunger and then I'll move the plunger up and down as I have that pressure change from its 9 bar to a much, much lower pressure as it fills up the other chamber to preheat. And then I'm going to effectively, as I spin and move it up and down just a little, because it has to be held on by something and have like, induction stuff and all that anyways. So it's like, yeah, obviously I have that in there. If you didn't think I have that in there, you're probably pretty stupid. It's just a type of thing that attaches to the plunger anyways to make sure it stays stable and it doesn't, and then also on the sides. And I just use some rods to clamp it down from outside. So they just need to be sealed. Simple stuff, not hard. And just spin them, spin the little things, and then they screw in, and then they're clamped. Right? So, because I started that, I was like, all right, well, I'll mix it a little bit. It's an argon, and it'll expand a little bit from its lower pressure until eventually you get to a much, much lower pressure below 1 atmosphere. That helps off gas any given amount of oxygen in that. Then I can, replace in new argon and then have that argon that was in the vacuum chamber get pumped out, cooled off with a basic radiator. So like this is a water to heat exchanger, but it's like this is going to be a big one. You know what I mean? Like I need it to boil off. Effectively, it gets percolated through water, right? And then like that then goes off to a heat exchanger, which is a water to air heat exchanger with then it's just a pump to a regular radiator, car radiator kind of stuff. So it's like as a result, I'm then able to remove a large amount of its heat and then recompress it back into the tank. As I'm condensing it from its much higher temperature, which, if you didn't understand, well, yes, I preheated it with that very hot argon, it's going to cool off as the box also happens to heat up, which makes it much easier to percolate it through the high pressure it is at into the water percolation cooling setup to heat exchanger area as the steam has to be condensed back down and the argon has to be run through until eventually I can get to a water to air in a sealed box that then takes the argon that was cooler but now isn't going to melt the heat exchanger, that then allows for it to then be cooled back down to ambient. Then it goes through a AC heat exchanger in a box that's sealed, and then it goes into the compressor that goes back into the tank. So it gets condensed to a lower degree of temperature and then gets heated back up during the compression stage, but that actually helps out with refilling the tank, as it can go through a compressor to a new, again, condenser stage, then back into another compressor as it's compressed air, and then eventually I can get it back into the tank. Now, that allows me to reuse that argon at some point in the future, which is a good thing. I'm going to need it because while it isn't as expensive as you would assume, after enough time, it does suck to buy more and more argon. So I'll reheat argon, repressurize by forcing in that argon. Just FYI, I suck out that argon truthfully back into the exchanger and then reheat it after I seed it and have mixed in the graphite. And I want to make sure it doesn't adhere the steel to the puck. We were talking about the steel this time, how I made the cylinder with the mold. So it's like I've got the oil lines, I've got the sides for the cooler, for the coolant that are, able to be built with the um, aluminum that I was going to build. Well, more just grind and then effectively place into a mold that's kind of built with the, after heating it up, preheating the mold, preheating the aluminum, and then squeezing it down to the hydraulic press in a vacuum. And because I grinded away some spots in the vacuum, it means that like it has less oxygen there. And because I heat it up, as I squeeze it down, it then forms because those are like relief cuts. It'll squeeze out or bend inwards to ultimately creating the proper sizing inside of the mold more easily with tighter tolerances. So I was like, well, I'll get to that, but first I need to make sure that I have like graphite dust on the top of this plunger, right? But it's like, no, well, yeah, but like actually, you know, eh. But it's like, all right, well, just I don't want it to stick. So I was like, I'm gonna put some graphite dust there and it'll mix or whatever. But it's like that's during the mixing part with the plunger because the plunger is basically only gonna briefly lift off to allow for the repressurization effect to occur. All right. And so like that's a funnel. It's like there's already a thing there that I can stick in, and then it's just place in like this funnel on top of it, screw it in, and then this has a seal top that I then place in the graphite, suck out the air, push it in, right? I suck out the air and I place in argon to the correct pressure, right? Well, it's actually more pressure if I'm being honest, but it's like that'll allow for it to get shot in from that funnel into the top of the basin where the steel is. Reheats things, but it's going to cool off, right? So it's like I have to wait for it to reheat up, and I had to put in the cooled off argon, and everything cools off. That's why it was so hot at first, and then it's going to get back down to like a decent temperature. This is another reason why it's like I preheated it with a basic kind of like forge, propane stuff, and then I use like the plasma, right, torch heat exchanger effect to pump it through and get it back up to like the right temperature so that way I can actually have it be a liquid, but with never needing to worry about it becoming oxidized. It's like I have to suck out the air, then I have to place in the argon, then I have to have that argon be a high enough pressure because it'll be reheated anyways, right? But the puck itself is preheated too, and I don't want it to get stuck to the steel or anything I put into it. So like different dusts help out with that type of effect. Anyways, that gets reheated up. I then spin it. So it's going through its little thread stage and it opens up the valve now, right? It's like, well, now it's in a vacuum, the the below vacuum chamber. It's getting IR blasted to keep, everything warm with a little bit of induction. I don't need a lot of induction because I'm going to plan on cooling this off slowly over time in a very specific way. So give me a second on that one. But it's like that steel then now is a higher carbon content steel. So it's like very specific amounts of graphite that I can put in. But like really realistically, I wasn't going to put in a lot anyways. You know what I mean? Because I didn't want it to really need this really high carbon content at all. Like it's not necessary. you know, it's a cylinder. It's mostly about like how I'm going to set up the mold that's being high pressure formed right now. So, anyways, as I place it into the mold, it's going to go over. So this is a different valve setup and a different mold capture for the liquid steel that I have here. So it's going to go over into like the tube that's for the inner diameter of the outer tube because there's an inner tube, and then like if there's more than I need, it'll spill over, all right, into the inner side tube. So it's like the whole thing. Wait a second, she wants to talk to me. All right, she's just playing with the dog or whatever. But it's like, all right, so the basic preheat stage, technically people would go like, it's not necessary. And I'm like, kind of necessary. Like if you can get it to like a higher temperature previously, before you have like the need to ultimately really heat up this damn box, which the longer it's hotter, the worse it kind of can become for you. So like all of this is something that you need to get done fairly quickly, right? So it's like it's not just a hot argon gas. I have microwave and IR blasters, which microwave is just fucking microwaves, with like a circuit to help and some cooling to help with like increasing their overall amount of microwave. that you can pump into a given area. And then the induction is another version of that, and IR is another version of that. So, like, it's all just to make sure the damn thing gets hot, right? But it's like it needs to get hot fast enough, but then also not get too hot for too long to where like materials are going to fail. So it needs to get hot where it needs to get hot, and it needs to be cooled where it needs to be cooled, and everything has to happen fairly quickly. That kind of thing. When I'm only working with like a small little amount, that's fairly easy to do. Mass is the arbiter in this instance of complexity to make it work. So, anyways, the basic premise turns into like, well, all right, so this is how you have to do like the mold, right? So the reason why I talked about it not being about like pressure forming is essentially what this is, because it's like, well, it's in a vacuum, sure, but like I'm just gonna have it drain out really quickly because it's in a vacuum and I have a very high pressure above that I'm plunging down, and the plunger helps with ultimately not having a bunch of argon gas get in. We're also allowing for a higher degree of speed to be achieved at being able to get the higher carbon steel into the mold after the mold has been pre-warmed and preformed. All right. So now the reason why I wanted it to flow over was because it was like, well, that's easy. I can just get out the hacksaw or whatever, and then I can just get it flattened down with a mill to the right specs that I'm looking for. You know, Simple stuff. I'm not looking for too extreme of a you know job ultimately for myself to fucking do after doing this. But we'll get to it on why it is that once it gets pressed in and it overfills, we're actually not fully done. And in fact, I am going to be squeezing it slightly after that at the top because, well, as it shoots down and it basically is a certain amount anyways, and I'm not going to place in there more than I really need, but if I did, then it'd have a place to flow in. But then that place to flow in is actually there as a result of, the top part of that valve, the plunger, helping effectively kind of like squeeze down. I'm outside, so I don't have to be interrupted, but I'm like cold. I'm in the shade. So like there's that. It is chilly. Anyways, it's gonna squeeze. So it's like that has to ultimately happen somehow. And so like that's the valve and that's the plunger, and then that's also why I actually have a little bit more metal than I need necessarily. Right? Because that allows for me to press in with the plunger to then be able to really make sure that it stays in a aligned kind of situation. Right? Then I dump in the argon to the bottom through a little valve area. And I'm going to talk about why that is. Because the basic premise is we're going to use this as a way to switch off the force induction in IR for a bit and then remove some of that heat from the box too and help with that pressure to help pressure force the mold. I'm going to place in some more argon that's fairly hot as well and continue pumping that in and create a greater and greater degree of pressure forming from the mold outside and the internal side of the tube, so that way it remains under a higher pressure with a lower reactive gas. Okay, then it's time to pump it out when it gets to a more solid-ish state. All right, then we're going to slowly cool it off. All right, this is where it's like, okay, we ain't getting it hot. We're going to let that argon slowly cool down, but it's still going to be in a state where it's like, well, actually, it's effectively just, you could theoretically still be able to, if you hit it hard enough, move it around, right? Like it's at that point where it's like still solid. It's for sure solid. You wouldn't really want to do that because, of course, it would remove its structural, integrity right now. But the reason why we're going to cool it down is because we're removing some of that pressure from that 9 bar we're at of psi, like 9 bar pressure for the argon gas, and then we're going to reintroduce colder argon, and so we're cooling it down under lower and lower amounts of pressure because the heat's removed. And eventually we'll remove that pressure, put it back into a vacuum after it's got back down to a room temperature. This is where the difference between, I think, other people and myself would be involved. I have a outside and inside nozzle for a valve opened of liquid nitrogen. I just talked about the liquid nitrogen before. Well, I'm going to be using liquid nitrogen again. So like slowly we're going to introduce a boiled off nitrogen gas that's very cold from liquid nitrogen. And eventually that's going to be recirculated and be used to help with keeping a colder tube that the gas is then uh, made sure to be warmed up a little bit more, so that way things don't freeze over and the liquid has a easier time getting all the way over to the box. Eventually it's going to be fully submerged in liquid nitrogen and then brought back up to temperature using that nitrogen again, but as a off-gassing to eventual, like, again, remember the compression and condensing stages to like a more cold, not so, uh, so it's like liquid nitrogen will still be able to be formed from a little bit of that capture as like a pre-cooling stage from gas that's getting progressively colder and more compressed. So I can form a little bit of that liquid nitrogen back, but then the rest of it's just various stages of gaseous nitrogen that is helping force more pressure into a given vessel, and then the outsides are just regular vessel, pressure vessels, right? Tanks. So that helps with insulation because after that it's just a standard vacuum insulation kind of tank. So that'll be over there because that'll come in handy later. At some point, I'll have to rebuy new liquid nitrogen, but this is a way to get around some of that and improve efficiencies. Anyways, it gets back to using the percolation. No, 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 I don't want ice. So it's like this is using the nitrogen off gas that was already going to be warmed up as like the pre-stage, and then eventually it can get to the water and everything else. And then it's back to atmospheric pressure with regular air, actually, and atmospheric temperature, again, room temperature. And so then it's time to take this out. And that way I don't have to do a type of pressure forming, although there's a little bit there, but then it's mostly gas pressure forming that then heats it up back to a proper uh, temperature and pressure, right? But we're not done yet because it's like, right, I now need to get this down to the proper micrometer sizes I'm looking for the piston cylinder I'm making, right? And so like this one turned into, well, there's a mill here I can get, but it's going to be, just encased in a box, and then I'll just move the platform, which is like a thread to a thread to a thread. So it's like this gear runs this thread, which this thread then runs this thread to, and so like this is a larger thread to a smaller threading to a smaller threading so I can get even greater tolerances. It can go vertical, it can go side to side. It can't do diagonal. It can spin though, which is nice because that's another type of gear to a gear to a gear for high accuracies. And so it was like, it's in a box that's in a vacuum, right? But it's like, no, fuck the vacuum. I'm just going to push it in with argon, right? With a decent pressurized argon. It's about 3 bar argon pressure, and then it still has this liquid lubricant, right? But then it's like, right, well, actually, because of the heat and how good argon is, and I have coolant there that's a lubricant too. If I have a lower pressure argon, then that'll actually help with it by having the boil away effect be used to keep it cool, and then I can have that sucked up still, but I just need it to be a low enough pressure to increase its degree of cooling from that given argon pressure, and then the lubricant coolant still performs incredibly well, right? So it's like, right, now I'll get the inside, which I was like, they have this thing called polycrystalline diamond. Like there's Zach Friedman on YouTube that did like this printer head thing that he talked about, that they make this printer head called that's out of polycrystalline diamond compound. So I was like, well, I can talk to them about getting like a proper, you know, like actual bit, right, to go onto this truck for the mill. I was like, well, I have to attach the platform and such, I have to attach the cylinder to the platform. So what I ended up doing was there's this spot that's an IR blasted, like little thing that like this is with this camera right here. It knows exactly where this spot is and it knows that's that center. But then I also have like on the chuck itself, like the polycrystalline bit. And so moving it until it feels this degree of, potential force from a piezoelectric kind of thing, then says, oh, that's exactly where it is, because it should be within a couple of nanometers of distance of exactness. So like it then corrects, it places in the parameters inside of the mill. That's just an open source software that then moves this side to side, up and down, and spins it. So these little chucks that then attach to it, kind of like, a lathe does, and you just, get it to within a certain distance, and then you tighten it, and then you have it correct and measure based upon, uh, the stuff I talk about. Then on top of it, also have the parameters that I have for that given thing that I have in it. Then also I make sure it's really stiff and stable where it's at, and now it's able to be used more properly as like an actual mill to get everything to spec that I'm looking for. So it will go through its own. I have to change out the bits, which means I have to pump out the argon, and then I have to pump in. It just needs like a pump to allow for the coolant to flow through, anyways. For where it's at, because like the bit stays where it's at. I just move the platform, so it knows how to move the platform just fine. And that works out great. It's perfect, truthfully. But the way I did it was that it's like, all right, well, I'll get it flat at the top where I need to. I'll get it tapered at the top too with this cool flat thing, and then I need to get the inside diameter, to a very specific exacting micrometer size, right? Which means I dump in the lubricant and you know, grease stuff, whatever, right? It's really just store bought lubricant, but it's like I need to pump it still into that, as it will take these little tiny chunks and then be able to flush it out. So it's like I can place in the tube deeper down, and as it rotates it from like its middle down to its bottom back up to its top, and then I flip it over, and then I do the same thing again, where I'll have it go from the middle down to the bottom, all the way up to its top. Now I get down to the micrometer size I'm looking for. Now it's going to then be tempered into the mold that I have. So it's like that's already kind of like a pre-hardened mold, you know what I mean? And so if I place in a little dust around it to make sure it's not going to have like any problems with coming out, I then go through a tempering cycle with argon. As I preheat the argon, then I use a little IR, and then I'll kind of like that with the induction furnace, right? And so like it'll heat it up from the outside, and then it heats up a little bit from the inside, and then it'll radiate out, slowly but surely, get right to the right temperatures, and then I make sure it's at the right pressure that I'm looking for during that with the argon gas, which is another 9 bar. And then I slowly bring it back down to the temperature in that pressure, and then I then remove the pressure and the argon, and I bring in a regular atmosphere, and it's now at the right temperature, at the right, uh, you know, pressure, and I take it out. And it doesn't stick to the mold anymore, but now it is a for sure hardened and tempered cylinder. Hardened steel, high carbon hardened steel, and tempered piston cylinder. And so it's like, well, I got the outside, made to have like the right, size and shape. Like while the mold is pretty close, I want to have it do really exacting parameters of tolerance, for both the inside diameter and the outside areas and everything like that, and make sure it all looks super neat and nice, you know. But now I have graphite, that I placed on the outside that helps a little bit with that carbon content on the outside, makes it a little bit more stiff there. And then on the inside now it's like, well, it's a little bit stiffer too, but it's more hard in that area during the tempering cycle as it'll re-expand into the mold. But during that expansion and tempering cycle, it also helps with like still being able to be a little flexible on the inside, which is what you're going to need, versus the outside, which you don't want it to do much. So it's like everything's now hunky-dory for the piston cylinder that I'm making. Which is the whole reason why I was doing it. So it's a hardened steel that now will do all the things I'm looking for it to do. And I was like, well, I'm getting further along. It's like a sandblasting, little chamber that I then can suck out air or put in argon or nitrogen or anything I really was looking for. So it's like, well, I got the engine, block made, right? Because it's like, well, that's the, like, it has 5 points of contact, and then I can clamp it because it's supposed to be like air and liquid cooled is what I was hoping for. So it's like, well, I'm gonna have fins there, right? But then it's like, right, I'm gonna be able to, with torque studs effectively in 5 spots, kind of like what they do with crankshafts, right? So that'll be good enough. I don't have to worry. And then like the top is effectively another version of like, well, actually these, areas where the aluminum is actually fit into this taper top area and then squish inwards to this little overhang that's there where this little flat out, like kind of rolled edge, but it's flat, and then it tapers up to like the real top part of the cylinder. So then with a little bit of high temperature silicone caulking, and truthfully it's not necessary, but it was like, right, I can then squeeze it in and it'll go into those little spots that then seal it, right? And then it's like, well, it'll go up, and then a little bit where that, like, area is for the aluminum, and then it'll seal in any gaps of air around that, and then I can just, X-Acto knife or razor blade that off and get it smooth and flat. Although there's going to be very little like actual that anything there, which was nice. I was fine with that because like it has good contact. It'll have oil and coolant around it anyways, because I'm going to both air and oil or liquid cool. Because while it's a single cylinder, I'm not really looking for a tiny single cylinder. I'm looking for a 1.2 liter cylinder, which is why I made this, which they don't really make those. So I was like, well, I'm balancing it instead with a harmonic balancer that's a pump that uses gears attached to this crank that I had to get from the cylinder of this big ass engine was 1.2 liters. So I had to go dunk, and it's like, well, I'm only going to use this amount, and then trim off all the excess weight from the crankshaft counterweight, right? It's a big, long ass fucking crank, huge, big boy, right? It's actually meant to be a longer to bore. So it's like this was supposed to be a big, long bore. I'm sorry, stroke to its bore size. So I was looking for a large amount of torque from this kind of design, but it's actually an offset crank that's going to have like a double elbow instead of wrist pin. So it's like the elbow then is at a specific angle and it has these little like bushing kind of things that stop it. Well, they're sort of like latches, but what it means is like I can place in this little girdle area to the bottomer. So I call them bottomers, right? But the heads and bottoms were made out of a regular steel, plate steel that I got that I then also added in like a aluminum. So I heat up the steel in the aluminum. I make little relief cuts, and it's like I bend them, form them, you know. But then it's like, right, but the aluminum is just going to go over that, and then I use these little studs and some nuts and washers with this silicone bushing material to then, with some Loctite, torque it to the right specs. And that's where the four corners that aren't were at the, so it's like the cross versus the corner areas of the plate for the heads and bottoms. That way it can then be very tightly put together, but I have high temperature silicone caulking again and some graphite paste. So that way it'll squeeze and form like a very tight seal between the two. But then it has these little overhang and relief areas in the mold for them to slot into, and it doesn't have that get to where it shouldn't get to. And I still have coolant lines and I still have oil lines. That kind of thing. Now, the reason why I have a bottomer is because it's going to have piston rings. So I have two oil piston rings and then compression rings that are there's three of them, right? The chromoly steel piston rod, connecting rod, is going to be machined and placed into it, to where it's like very, very tight gap tolerance. But now it has oil there, and it's a hollow tube for a reason. It's about 1.25 inches, and then it's like, well, with the like mill, but it's really kind of a CNC, if we're being honest. It's going to grind in a inside double helical with this little wave pattern vertical thing, rifling effectively. So that way it's stiffer and thinner and less weight. Now, the reason why I do this is because the piston head I'm making has hollow holes in the center, but of course it's still joined at the top, but it's like it has a hollow area, and then I have like tubes that go out to the oil return. Now, the reason why I'm talking about this like little girdle is because there's oil return along the sides, but the oil rings actually add in for the little holes at the bottom when it goes up to the top with this, oil pump, and it squirts it in to the hollow too. Anyways, but that always uh, is inside of this little girdle area, and so it'll change its diameter for like the journal that I have. So it's like think two-stroke engine sort of stuff, where it's like these are valves, and then as it rotates, it then closes those valve areas, but then it squishes in the oil that was in there off to the sides. But then when it also gets to a certain point, those valves are now closed as well, and then it changes its overall position where it's at, and makes a smaller volume of area. And but the valves that are always there open in the hollow piston connecting rod, then go and fire up that oil through up to the piston head as it's still moving down. And then these holes that are there along the sides of the piston head, which are ring valved. So like it's a rotating ring valve that sits on like, kind of like bearing journals again, but it has oil there, and it has like a gear that helps it move up and down with that acts like a prop, like a airplane where they had this little bump on the shaft that would tell when the gun would stop firing. So that way you didn't shoot your prop to smithereens, that kind of thing, right? So it's like the ring valve has two ring valves that are around it that have these T junctions at the edges, and then they fit in with like these other types of round junctions, to each other. And so like they'll rotate, but they'll always be statically fixed to where they are based upon this little latch design I have. So it's like they go tick, 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 and then like they'll latch together. So like they're opposing, right? Over one side has a kind of cutaway area. Another side in the center, that's what we mostly use, or you're mostly going to use as your main valve. So as it slides through, it then exposes a through point for the ring journal valve thing I'm talking about, right? But the other side has a opposing equal amount of weight removed from the two of them, and they work together in conjunction into like these little slotted areas together with the engine block, as you'll just push them through, and then you'll latch them together, and you'll push the next one, that's the center one, through, and then you'll latch it. You just got to make sure it's, I mark them, but it's on the opposite side, so that way they're always balanced. Now the reason why I have the gear that will change when it is larger and smaller is so that way it can go up and down, be exposed or not exposed, as it'll be a two-stroke if you keep it like that. But then that means it can go down with oil pressure, and the gear here that changes when it will be exposed or not. For four-stroke ring valve, they're for the heads and the side of the cylinder wall. The exhaust port goes inwards down to the bottomer area side of the cylinder. It's a multi-tube triple wall vacuum insulation, but they also has some ceramic that's actually kind of thin on that side. But the reason why is because I want it to be less able to exhaust its heat and lose its given performance to the system I was creating. So it's like I decided to redo the idea of how engines will work based upon how rockets work and one stroke designs work. So it's like the exhaust is a four-stroke exhaust, but there's only one exhaust. And it goes to that. That's it. Right? I have 3 spark plugs and 3 injectors. Okay? So, uh, with one fuel injector. It's one fuel injector. So, it's a big boy injector, but the other injectors, the 3 injectors, are actually air injectors. They're big old diesel solenoid activated kind of fucks that have a air rail pressure system. So the reason why I did that is because I'm going to pump in gas first. It'll vaporize in a near vacuum because, okay, so let's get back to the piston head. It has 3 compression rings at the top and 2 compression rings at the bottom with an oil ring in the middle. Right, and the piston skirts are effectively both top and bottom, where they'll have these like little crown designs, where it's like little wave guides that are bigger, but they're small, like little small piston skirts here. And then like there's a little smaller piston skirt with little waves there, and then there's 4. So there's 2 and 2 big ones, and then there's 2 and 2 small ones. You know, equal where they are. Okay. Now I have this little box area that goes around this wrist pin sort of action. Now, the only reason why I had the wrist pin was because I needed 3 wrist pins where it would change its based upon where it's moving, or the with these shims for the box, so they can extend a little bit and compress a little bit. So think like a T-junction, like the sliding valves I have. Right. The reason why I did that is so that way it would change its valving. As it compressed, it wouldn't go past a certain point, but there's also these little latches on the wrist pins themselves. But then that would close valves that are there. So that way the oil would just off to the sides. It keeps oil at the rings now, but like I have another oil, remember that sliding valve ring I talked about? Well, there's 4 holes just above where the intake and exhaust at the bottom is, or the bottom part of that, cylinder is. So it's like as it would go up, because it's timed to the crankshaft, it would go down, and then the thing would extend as it would slow down based upon the offset of the crank with the double elbow to the connecting rod would be, which would be seated in that little girdle I was talking about. So it's like as it would rotate with this pretty significant offset, it would then create kind of like an oval. So it would go, pretty much like the entire duration of the power stroke would be pretty good at being able to give me, energy, torque energy to the crank, right? Or its pressure. But that means it's like, actually it's around that 1 to 2 o'clock position with the double elbows, and then it would then suddenly go whoosh, like a little J hook at the bottom, and then whoosh at the top. So it's like, as it would turn, it would then rapidly change in a very different way at the bottom. So it'd go pretty much stable throughout the entire duration of the bottom, power stroke and exhaust stroke or compression and so on, right? But then it would suddenly dip down for both top and bottom. But then it would stay there for a little bit, and then it would rapidly start. So a good way to put it is like, as it gets towards top dead, it would go whoop, and then it would slowly go down, right? And then it would whoop, and then it would slowly go up. And it's whoop, and then slowly go down. So it would be more consistent the entire power stroke and exhaust stroke and so on, right? But that's the double elbow, and that's like a certain distance for the elbow that's connected to the connecting rod, where that bearing is, and then the other bearing that's connected to the actual rod that connects to the actual crankshaft. So it's like this is an in-between that has a certain length that allows only a certain amount of movement, that only allows for this kind of action to occur with the crankshaft rotation. It's geometry physics, effectively. It's like it's given angles, but then because of those given angles and how like it's a perfect circle for the crank, right? It then only allows for this to occur, as it has different top dead centers and bottom dead centers, but it's a longer stroke now length with a long big ass crank that allows for this to occur for this given lengths, and only allowed to travel so far and over. basically. It's never going to be fully in line kind of a thing to be able to do that, but then that means I have for the exhaust, it can push up, you know, from that exhaust, but it's more equalizing that pressure, okay? Just FYI, I'm getting back that given torque because I'm not using flywheel energy to push back the piston head up to top dead center during exhaust. And I'll get to that a little bit, but that's the reason why I did that for that exhaust going down there, and then that's the intake for the exhaust, and then once it goes to intake stroke at the top at the top part of the chamber, that's exhausting off into the turbo that I'm using. Okay, so like that's forced induction, which I have a super turbo for this with a pressurized chamber design. So like it has a one-way valve area for where the turbo compressor part is, and then it's a one-way valve, so it has I go through a air to air into a liquid to air at the bottom. So it's like small little air to air at the bottom, and then it goes through that we're gonna have like a standard radiator, and it has to go through the bottom part of that radiator. It's not the radiator, that's the liquid cooler. It's separate. It's just that's an area where I can put the liquid, and then the air to liquid radiator is right next to in front of that engine radiator. So that's like where the exchanger from the air to air for that part goes to. Then it goes through a nitrogen filter. It separates nitrogen into a one-way valve system for the oxygen, and then the nitrogen. The nitrogen has a blow-off valve at 65 psi that then always blows off into behind the exhaust area of the turbine, reducing back pressure. And then I have this little teardrop valve, which I've talked about previously, which has a little overhang in the center where the tail is, and then it has a certain gap distance for where the hemisphere part, the bulbous part, is, but then like that's free floating. And then I have these hinge tails parts, so it's like that's when it closes, it means it has this little air go around it, and then when it closes, because it's the gap has created enough of a vacuum in front of it for the hemisphere to close, then whatever pressure is there that might be there opens up the hinges of the tail, and then that exposes an area where the valve in the center, because it's hollow, goes through into that, and then it fills up the overhang, and then that hemisphere head stays there, and then it'll suck out from the overhang until it equalizes in the center where there's enough pressure to keep the bulbous part of the teardrop valve area closed, and then the tail kind of just remains closed as well, so that's pressure there, but then it's then drawing a vacuum from where the nitrogen gets shoved off into behind where the exhaust comes out of the turbine. But it's not just where the turbine is. There's a given pressure valve. Yeah, of course, you need to show up. Okay. All right, so I got that done. But it's like, where was I? All right, so crankshaft. So the girdle here is a sealed system kind of setup where it's like oil will drain off the sides into the top from the oil like return thing, and then like the oil that goes through the piston rings, which there's valves one side and another, but it's like they're going to be closed as they go into the girdle area at the top, but then they're closed also at the bottom journal area. It's in a sealed system, so like it'll go push through into that area, and then it'll push up, but then like the valve, for the sides, because it's a hollow tube of steel that's able to handle the pressures and everything, but then it's like able to then, as it rotates with the connecting, I think it's like a dog bone or whatever, it's got two connections at the sides and two connections at the bottom, you know what I mean, with a like just solid kind of material, steel in this instance, that's machined to help with the whole thing. But then as it rotates, it's like, well, it's going to expose like a two-stroke for the hollow area, and then like as it changes its volume as it goes down too, but then also rotates, it then allows for it to go into the hollow tube that then pushes off to the sides, which is where the oil from the top will go down into those side areas, which will then drain off into the sump area, which is a dry sump anyways. Right? All of that works. The valve thing works in terms of that side of things. Oh, right. I was talking about where the nitrogen is. So it's like goes into the bottom. So I have a crankcase vent and a header vent. All right. So it's like, I'll get to that. There's like that crankcase and header vent, as there's still whatever residual exhaust that's in the exhaust tube from that port is another version of like, well, I'll suck out the remaining and I'll suck out any of the header and crankcase vent, crankcase pressure into that. And then once that, which is timed with the gearing here, closes off both the exhaust and the intake as it goes down, exposes like those little other two, and then the other, intake. So it's like the intake exhaust as it rotates, because it's got oil, fresh oil that constantly comes around and it has coolant around that. So it's always a cooled fresh oil valve journal thing. But it's like, that's fine, truthfully. It never expands too much, never has any wear. That's like something that you wouldn't be able to get to and just replace with a basic gear system. But it's like that allows for that exposing of the valve setup for the nitrogen to come in, but it's like that's a tube line from the nitrogen line, which is a one-way valve, which is a blow-off valve. So it's like a one-way valve from that blow-off valve that just will constantly blow off once it gets to that pressure into the turbine, right? But it's like I don't always want it to be, giving me nitrogen to the bottom, right, during that cycle. So it's like it'll trip the valve there, but I only want it to be at most half of that pressure from that line that goes into a turbine behind that turbine area, which is another version of like behind that turbine area is like, oh, guess what? The teardrop valve into the exhaust area. So it's sealed on the one side, then it's still spinning, of course, and then it's now taking more and more because like the teardrop is a different type of teardrop. So as I have a teardrop that's hollow, that has like the little gap thing that I talk about, and like it has these little areas where it has to connect that teardrop. Remember, like those are 4 spots that have to connect that teardrop to the inside of the tube. If you didn't think it had that, well, you should have thought that it had that, because that's stupid. How would it stay there? Right. So it's like the one that's over by the exhaust, that is hollow, but it's not gonna, for the stator is gonna have any other extra come in. The one behind is hollow, but it has that nitrogen come in there, and then also for this other funnel. So like this, instead of having the little hinge system, because I don't care about that, instead it has a funnel just slightly inside of the tail part of the teardrop. So it's like, think parabolic funnel, right, with some little elongated waveguides, but it's like the funnel part, it's really kind of just hollow-ish, right? Like I'm going to have some of that nitrogen come in through that, and then it'll be slightly wider and shaped like a teardrop that then gets to a smaller point, but then the rest of it goes through a little waveguide tail area that has the nitrogen come in. And then what that means is as air goes around, it's got accelerated, but it still sees it as kind of roughly the same size of volume for that teardrop area. But it's like, I actually kind of don't want it to do much in terms of that nitrogen. So like it's a one-way valve sort of setup that mostly goes to where the funnel is. And then that's just mostly a kind of like seal system where like the head will just seal off. And then like this pressure area isn't really there. Like, put it this way, like I want to make sure that it's gonna, if there is a genuine vacuum there, it would seal, but it should never really fully have a vacuum there. Instead, like, mostly just make sure that, like, most of the nitrogen's coming through that funnel area, all right, that then it'll see a lower pressure zone behind that teardrop part that will only fill up the hollow teardrop part if there's enough of a significant vacuum where the turbine is. So that way it'll push that air through still, and that nitrogen now is the main blow off valve. Okay, like that's the blow off valve, part. But then it's like, well, it'll only take half of that pressure and put it into the bottom part, which is drawing a vacuum, which is timed, to the bottomer area, which has a compression ring, and then compression ring for like the hollow piston rod, right? As it extends back up, it then, seals itself back up until it yanks itself far enough down, and then it squeezes at the bottom where the elbow, joint, double joint or connection or whatever it is for where that oil squirt to the rings are. So it always gets fresh oil for the oil rings and the piston skirts and everything for the piston head, while cooling the piston head too. And the piston rod. So it's like everything's cooled. So it's like as it goes down, it then has an equalization, then it produces much more of a vacuum, and then it goes with a bunch of nitrogen. That's half that pressure, but it's much lower pressure, even though you wouldn't think it is during that compression stroke initially, and then it like equalizes a little bit of that, and then it's like, well, whatever at the top. And I still have a flywheel, so it's like a smaller amount of flywheel is necessary now. Less parasitic loss. It's a good thing. So I have a whole flywheel vacuum thing where it's like, how clutches open up? Well, it's like if I have rods with a vacuum that then has a pressure somewhere else as it's trying to get to the vacuum area, then it'll move like a given mass volume to get to that. But it's like, then it extends from a further out link to a closer area length, which means I can have less mass over here and it's not going to move this mass, and then more mass here where it's closer for the idle and then mid-range and then top end. So I have even more efficiency, which is the whole reason I was doing it. So that nitrogen goes in, and then it gets repressurized during the power stroke, right? And then it exhausts it out. So it's like, exhaust, go out, as it goes down, and then pushes that nitrogen pressure into the turbine of the turbo, the super turbo that we're using. So remember that crankshaft thing I was talking about? So like a harmonic balancer, and then there's this Formula One style like suspension or a spring that they use, so it would rotate this given mass, and it would go up and down while it did it. That's my counterbalance weight for side to side, for the arc area versus during a power stroke, right? And then the up and down for when it's at its version of top dead center and bottom dead center. Now, the reason why it's an oil pump and a coolant pump is because as it goes up and down, there's a diaphragm attached to that with the coolant for the suspension, right? The spring that they're using that's rotating, but it only rotates a little bit. But it's hollow, so that way I have an axle that goes up to the top and the bottom with a differential that attaches to a stator. So there's a differential that attaches to like a pulley system kind of thing that I use to go with the super turbo. I do have a stator, which is actually it's just a generator, but it's two of them. There are 8, coils, but then there's coils that are horizontal and vertical that intersect each other, and they're 2 packs. And then I have magnets for the 3 for front, middle, and rear, and then top and bottom. So that way I can get, and they're offset, they have to be offset, so that way it would trigger when there is no magnets there for another area, so that way it doesn't interfere. So I have more electricity generated from my 1.2 liter fully balanced single cylinder concept. I have a pressurized cylinder of regular air, but it's like once I start it up and I start running it for a while, the compressor itself will store in all the one-way valve, which I should let you know, after the nitrogen filter, it goes through another air to air, and then it goes through the water to air exchange, and then the secondary water to air intercooler is in front of the radiator, which is at the top now. So it's like, this is chunky boy air to air. And it's like, well, this radiator only needs to be about this big. And then the rest of it's like water to air and water to air heat exchangers, coolers that are in front. And they have 140 millimeters, for the water to air. But then the rest of it's just regular air cooling for, when you're moving, it's supposed to be for a motorcycle. So 1.2 liter motorcycle single cylinder that has the bottomer area as just an extra torque, parasitic loss reducer. So it's like parasitic loss from that exhaust that goes into helping with the traveling up of the piston, which is lower mass from the flywheel now necessary to gain continuation of operation of the engine. Then it's fully balanced with gears that are shaped specifically to move the harmonic balancer with the oil it has to pump at that moment, and then it doesn't move it as much, really practically at all during the other moments. So it's like a flat, so it's like gear teeth on the crankshaft, which are different amounts in those areas attached to like a flat coin that then rotates with different gear teeth, and then it's just long, wider circle and then flat part, so it doesn't need it during that moment. And then the suspension is a hollow, and it just needs to spin and rotate during its counterbalance points, as it will go up and down during that anyways, with the gear teeth thing. And then the differential is just a gear and a housing that goes and sends its counterbalance weight to that, which is now the pump. And so it doesn't need to spin as much, and it can be a smaller mass to still be able to pump coolant. So now it's fully balanced, right? It's like, well, that exhaust is going to go into the cylinder. Well, you're right, but I'm also pumping in gasoline fuel with very little air, so it can't combust as it goes towards its intake stroke. So it's like the air injectors, there's 3 of them, which are slightly angled upward, counter style. So they're modified diesels that have a quartz, like high temperature quartz and ceramic outside. I had to drill in them to make them larger, but then the 65 psi will go through its injector and then come out as a 25 to 5,000 psi, depending on what you're doing with the sizing of that nozzle. So it's like the manifold, air pressure manifold, is an entirely different setup too, where it goes in as it's, because I'm dividing that 65 right into 32 and a half. So it's like one-way valve into the oxygen rich side that then goes into the vessel that holds that. So it's like that's a tank that holds that pressure, and then there's a one-way valve going out of that into the air to air and then water to air, and then that must go into the bifurcation or trifurcation in this instance. So it's like this is one single tube that got pushed into 3 tubes, but that's another version of a one-way valve right before that separation, and then that goes into the 3 injectors that are solenoid activated, which they have those for diesels. Didn't know, now you know. And you can modify injectors. If you didn't know, now you know. They can have quartz tubes. If you didn't know, now you know. And if you didn't know about high temperature ceramic, well, now you know. The injector are, angled, which if you didn't know, they can do that. So I made my own heads. So like, if you didn't know, now you know. They have larger regular fuel direct injectors. Those are very high pressures, but I don't really need the high pressures because it's pretty much going to be in a vacuum anyways as the exhaust goes out. But it's like, I'll just pump in a little bit of fuel as it goes for its intake stroke with a little bit of air, just a small amount. I'm just looking to start a spark. So spark plugs, they're behind right where the injectors that are angled diagonally inwards to the inside diameter and slightly up, versus the one at the very top next to where the spark plug is too. So that way it's angled in the direction of travel that are counter. So it's trying to spin that injection of air. And then the ground area of the spark plug is right next to where the injector area is with that little quartz and then that little ceramic that allows for like a spark gap because we run a little bit of electricity there that allows for, as it tries to carve that air that's going to be moved over to off to the side with the direction of travel. And then the spark basically creates a little bit of a plasma gap that tries to force that hot ass air and fuel away from my injectors to not melt them. Same thing for the one at the top. So it's like as I push in, all right. So from the 3 air injectors here, which are diesel, like I can't use my any methane. So like methane doesn't have enough volumetric flow for that to actually work. They need to be big boy chunkers to really force in enough air, right? But it's like, so those air injectors from the trifurcation areas, that's the direct line in. Then they have tubes that run to each other one. So it's like the center one would go off to the sides, but those are now one-way valves. And then the side ones go to the center one and the other opposite side. So it's like center and the other side. So those are also one-way valves that are bifurcated, right? So like that way it maintains its pressure, but as it fires, because I have to 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and I could fire them all together, but it wouldn't be as efficient as it would suck in air, and then it would have a little bit left over, but then it wouldn't continue its flow, kind of like a valve setup, where you would want that air that's already moving to go somewhere else that can be used immediately from its given tank of air, and then improve the efficiency of each fire cycle for the pulse and pulse duration or overall duration of the given pulse, for the air injectors. The idea was to get around some of the inadequacies of efficiency of single cylinder designs and most engine designs, if I'm being honest. Like that's all it was about. So like it's fully balanced now. It's got an offset crank that gives me huge crank rotation, which gives me greater amounts of torque. It's a 1.2 liter that's fully balanced and has a different setup and style for its flywheel. Then I can pump in the right amount of fuel for idle and then pump in more and more fuel with a fuel reservoir and then direct injector. So as I'm pumping in fuel, it'll evaporate off the cylinder sidewalls, and then that heat energy with spark, as I don't have to care very much about how hot that air is, it's more about the fact that there's oxygen, higher oxygen rich environment in that air that got cooled after it got cooled. So it gets pre-cooled, goes through a filter. That's why the compressors got a multitude of different one-way valves, both going in and then after. So that way it maintains its pressure. So it can always work once you start it up again, and then it can dynamically maintain a higher degree of rotation for the given turbine turbo setup, as it's a super turbo, which changes its initial during idle with the lack of pressure. It'll use the pressure in the lines, and then it'll spool up the turbo, and then it changes the gearing of the super part of the supercharger, and then allows for it to maintain a high enough pressure to maintain it at idle, and then it'll ramp it up, and then eventually switch over to the turbo part. So as it fires in air, it then will always circulate the air and fuel mixture, which allows for it to fully burn with less nitrogen in the combustion chamber because of the nitrogen filter I'm using, a higher amount of burn to fuel, so I can dynamically play with higher heats or lower heats and have a complete burn and use a little bit of extra air on its way out to have like a scavenging effect with the pulsing of the air injectors to help with complete evacuation of the amount of exhaust and improve efficiencies, which the head both has oil and liquid cooling, sure, but also has, like a little air heatsink fins. So it's always cooled, for what it's worth, more than adequately, because the gas will soak up the cylinder sidewall heat, and then the liquid cooling, if it ever gets hot enough, will dump it into the radiator, and then I still have air cooling just fine for what it is. And then the material of the diesel injectors will survive the heat of the higher heats of the gas, burning with fresh air, higher oxygen air, and it's not that big of a deal that it's going to burn faster because I pulse them to help with mixing and can get a longer power duration stroke completed and a fuller exhaust cycle stroke that helps with my exhaust to the bottom, exhaust chamber area effect that I'm looking for. I was able to get 227 from a prototype here idea, foot-pounds of torque at 9,000 RPM. I'd love to work for someone and make it, but like for what it's worth, I don't have any credentials or anything. I'm just a really smart person. So it's unlikely I'll ever get hired. But the whole point was right, I wanted to make a very balanced, up to 28K is what I managed to get to, engine. And the piston head, for what it's worth, is a magnesium, silicon, aluminum carbide combo that I wanted to talk about further, which is all meant to go to this given idea of an engine. I was like, oh, I hate hyper-eutectics. I want to make my own. I'm already making my own. So I was like, I wonder if I would be able to do it. And it's like the chemistry works out, the pressures work out, all of it works for making this type of material. I can make this type of material. Let's do it. It's now very light, insanely strong. It's hollow, it's cooled, but also it takes heat away very quickly. It's able to take very high pressures and tensile strengths, and is incredibly good at having almost no creep at all to no creep at all, depending on how high the heat we're really talking about. Like by the time it has creep, it's starting to melt again. So I don't really consider that like actual creep. So it's a composite material hybrid, but it's not, because it's like carbide doesn't usually form with aluminum, but then it's like, right, but then during that compression stage and shear off during exothermic, or in this instance, thermal shock, as it's gooey and it's slightly tacky, and then it's definitely solid on the outside. It's like freeze, right? And then it compresses itself, and then like a little bit more pressure will then add in that extra like hit effectively, and then it's like put into the mill. So like a good way to put it was like I had a hollow like rod at the bottom that has these little arms that stick out that are 8 of them, but then it's like I have this other one that's going to press in, and then the other sides are going to press in, and so it has to go from the bottom along the sides over the tube of aluminum, and I have a plate of aluminum. So as I have a tube of aluminum, a plate of aluminum. And so I go along the plate of aluminum along this, or the tubes of aluminum along the side, will go up to the plate, and there's silicon dust that's there with graphite. So I had to put graphite paste, or I'm sorry, graphite dust, and then magnesium. So it's like, I have to do that, right? And it's like, well, with the silicon, it's in a vacuum, right? So it's like, and I'm then plunging it down. It creates pressure along the sides, and then that's warming it up, and then it's cooling out the magnesium, but then I'm IR blasting it anyways, and then it's like, right, then I'm going to force in that magnesium graphite compound together, which normally doesn't want to like do anything because they're different densities, so it'll stick up to the top. But it's like when I'm doing it this way, then it's like going to force it to continue its mixing. So like the silicon gets drawn in to the silicon along with the aluminum towards the bottom of the magnesium. It's going to make it gooey because magnesium takes a lot of heat to ultimately melt versus aluminum. But the aluminum also needs to, in order for it to go up and the flow of the magnesium to continue, it has to fully melt, and it'll just sink in from the sides, and then it has to go around that mold now to the bottom, and then that plate will then melt, which is going to go through the hollow part. All right, and then it's like that side part then squeezes to the hollow part, and then it goes around the hollow, rod with the little, things off to the side, goes around up. So it's like at first it melted a little bit, and then it's going to go up to this other part. So it's like this is a little like dome, kind of like looking aerospike sort of situation where it's kind of like a bell curve, right, off to where the stators are and the piston rings that are on the sides of the mold, right? So it's like now it's melted and it's been basically moving everything and mixing everything, and then it's been compressing it as it forces it up to the top of the dome. So it's like squeeze, 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 and then it seals up the hollow, and then it has to go through and around the stators and the piston, ring gap areas, fully fills up the thing, and it has a little bit of a over the top part that like I'm also forcing in a little bit of extra magnesium at the top, and then it has like an actual base, like a solid puck at the top that it can then spill into, which then means it's compressing and forming its heat, right? So it's like, right, I have to wait for it to cool off just a little. I'm pushing in the argon, and then we're going to put in the pressure, argon pressure and heat, turn off the IR blasters, and then it's like, and I have to wait for it to get to gooey in the center, and then like, it's definitely a solid on the outside, and then it's a little tacky in between, and then we fire in from the sides liquid nitrogen while also compressing the molds. It's fine. I'm going to mill it down to like the right specs anyways. So it's like if the mold doesn't fully like stick together, it's whatever, I don't care. So it's just like pressure, 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 and then it's like thermal shock that bastard, and it'll create these little tendrils of thermal shock, like shear, like slate lines they could shear off, but because they're like vertical, horizontal, diagonal, and then Z diagonals that all form, and then eventually under like when it fully submerges itself, because like that's at first, and then like the thermals will go outwards, and then they oscillate effectively, right? So it's like pressure outside, heat, and then it's like that's the shear part that it starts creating, and then it'll like rub, and anyways, point is, eventually enough liquid nitrogen is there, it submerges it, but like you have to fill it in with initially liquid and gas together, and then eventually you'll get to full nitrogen. So it's a very specific, slow process, truthfully, that gets to that point, and then I have to put it under that pressure, right? And then it's like slowly bring it back to atmospheric pressure and temperature, which then there's a whole reformation cycle. So reformation cycle is like the heat cycle process. So once I got to like atmospheric temperature and pressure, it's like put in the argon again and reheat it to a different, it's higher than it would average normally be for steel to do a temper cycle. And then you have to like much much more slowly under that pressure bring it back down to atmospheric and slowly remove that pressure over time. And then it's like time to mill it. And well, it's really hard, it turns out. It's a good thing I have a polycrystalline diamond bit, I'll tell you that much. This fucker doesn't care about like any diamond. It's like stupidly good at removing heat. It's stupid dense and it weighs like nothing. It's really hard. And it's light as fuck. And it's like, it's a slightly stiffer, harder aluminum alloy that I use. It's just like online, whatever. It's like a standard aluminum. So like whatever that was and whatever oxygen in the aluminum might have been there. All right. So making the compound, the only reason why I was doing it wasn't just for the piston head. I needed something that was hard and light. And I figured, well, this would get like close to because it's aluminum, magnesium, and some uh, graphite, right? And so it's like, it's not going to be like, right, it'll be able to handle the harder surface of the hardened steel effectively that's been tempered, right? But it was like, oh, it turns out what it looks like is like the structure inside, those little shear lines turned into a bunch of monkey hands that connect like as a bunch of overhangs on a molecular level. And then there's some, well, not some, a bunch of covalent bonds of connection between the structure that mean like it's very difficult to break apart. That normally wouldn't be there. But because it's formed this way, they show up. So effectively, I created a much harder piston head than like the actual surface of the inner diameter of the piston uh, cylinder that I had made. Like it's insanely harder than that. So it would wear away maybe, except for the fact that like tolerances were so fucking good and it had like no creep at all that it just never mattered. And it had so much cooling that it never gave a shit. And the piston rings, well, I had 5 total with the Nola ring in the middle. I had made them with the mill that have these little so it's like, think offset little waves and then a middle like hollow area and then like the proper gap that has like a little Z line zigzag tooth pattern for each one of them to go into. Same thing with the overhang area of the piston ring. Well, the piston ring areas for the head had those little overhang like things too, and it means that it's like they had very little like contact in those spots. So like basically nothing ever got around the piston rings, and I never really had to worry about blow by. But if there was, it's like, well, it's just sucking it up into the vacuum or into the compression or the intake stroke, right? So I just never really had to worry. Anyways, Uh, the other thing for like where it connects to the actual crank for that connection rod to the double elbow pin, which has to be, those are very specific sizes and everything, which are another version of uh, a chromoly with a slight offset for the actual connecting part bearing for the piston, not the piston, the where the crankshaft is to the elbow. So there's a slight offset, and that allows for it to do what I'm looking for it to do in the like oval shape of power and exhaust. So they had a extraordinarily well balanced setup that has very low weight. It's a dry sump to begin with. The oil pretty much just drains off into a little separated bottom part that doesn't slosh the oil around too much. But then during that, it's spraying on oil and dripping oil onto the bearing journals, and uh, so I never really had to care about not having enough oil for the crankshaft area and the elbow connection to the up and down part that's vertical, only ever vertical for the piston head, which while it's dense and it's very hard, it's also very lightweight, like weighs next to nothing. Um, but I wanted to get it finished. So I was just like, I'm not making everything out of this. This sucks. Like I want to play around with this, but no, I'm not making everything out of this. I want to get my fucking, prototype done. It's a prototype. So it's like, I got the whole thing figured out. It's like a little teardrop shape that's in line. And then if you were to look from behind to the front of the motorcycle, so rear wheel to front wheel, it would come off to the right where the crankcase and then the offset stuff, for the girdle, and then the bottomer to the girdle, and then the crankcase is, the crank is too, and the pump and all the rest of it. So I have to have axles, which are smaller and thinner, but that means like it has less weight than a pulley for a given size of this engine, and it has more strength and durability as a result of the high, perfect, well, nearly, balancing. We're talking it's into the micron nano-sized area for balancing offset. Because it's like, well, during this, it's like this is an oil for return or off to that for the, and it's like I separated the turbine and compressor area. It's like it has to have an aluminum plate that mounts off to the left side, directly from the left side where the exhaust, because the exhaust is on the right side, and then it goes inwards, and then it goes off to the left side to where the super turbo area is, which is a larger turbine because I have a super turbo to compressor. It's like the compressor was like kind of like meant for a 1.2 liter engine, right? But like I have a larger turbine area for like one step up. So it's like, well, I'm going to balance this with an axle, and I need to have like the axle have that pulley system work. And then once the super turbo gets to the supercharger part for the pulley gets to a certain rotational speed, it then would disconnect, and then it'd run off just the turbine, right? But then if that kept going, then it would hook into the alternator, because like the balancers and pump and all that should never get overspun, but I had some gearing and some and whatnot, so like it would feed into those, and that'd take off parasitic loss, but still make sure that it's like at the right rotational speed. But then eventually it'll hook into the crankshaft. Like if it got really fast, it would hook into the crankshaft. So that way, like the exhaust would always feed into reducing parasitic loss until eventually it added into torque and horsepower. So it's like the exhaust was already moving, and then the intake for the compressor was already which is a ram air. I should talk about that, but it's like a bunch of side ram for like where the radiator areas is, and then they combine into a singular like intake, which is a big boy cone, with like another filter in the flat part of the head, and then there'd be these like little hinge valves, right? Which would then, if it ever happened to flutter, they would seal up, and it would just spray in that seal area any of the excess. Well, it wouldn't spray in the air. That would go through the filter. So it's like the blow off valves for everything would go into the filter area, and then it would try and push that through and then suck it through the lines with a bunch of one-way valves. So that way it is more efficient overall. So then for the exhaust from that turbine, it's like it's always drawing a vacuum into that, right? And eventually it'll seal, so I don't have to worry. And then it would just store the oxygen and nitrogen rich air into tanks from that filter area, so I could always use that from the lines and everything else as a way to start the engine. So I didn't ever have to worry about needing an extra bottle, but I had a bottle of the same air at a higher pressure that's been compressed, the big old tank. Then I had that as a part of underneath my seat, and then eventually realized I didn't even ever really need it. Like once it started going, I just never needed it. It was literally never used. So I was just like, what the fuck is this for? But some people might need it if they didn't properly one-way valve and seal their lines. The engine worked just fine for my air injectors. I have 3 air injectors, big boys. Well, they can go to 25 to 5,000 psi. It's more about volumetric flow rather than psi. So it's like it starts off at around that 1500 psi, which I have a multi-layer steel with a high temperature silicone and graphite paste. Uh, that after I clamp the sides, I have to then put in the exhaust tube, because that means I can actually clamp, because it goes into the bottomer as a bolt system. So it's like then I can clamp the top and bottom for the heads, and then actually make the whole engine a one complete part. So it's like how Subaru engine's a flat four, and then like you have to get these big long studs and you have to clamp them together. Same thing. So it's like you have to clamp the sides because it's a split engine block, and then you have to clamp the top and bottom, so headers and bottomers, and then you can then put in the girdle and crankcase together. So yeah, a lot of bolts, but then it's fine because I have the high temperature silicone caulking with the graphite paste, and then studs torqued, and like this was like 30 foot-pounds of torque for everything effectively. So the bearings were their own version of like whatever high performance bearings for crankshafts are, and they had very little weight for the crankshaft besides like the gears that I was using. So uh, that's all that was really necessary for that, and it really compacted the design because like it's a teardrop shape for the heatsink fins, airfoil stuff, that then had like the the radiator and air to air and water to air heat exchangers, intercoolers, whatever you want to call them, radiators, intercoolers, heat exchangers, it's all the same thing to me. Force in its air into where the heatsink fins are, and then I had for idle the one dual 140 millimeters, right? But it's more than good enough for a tiny little engine. But I'm talking 227 foot-pounds of torque at 9,000, which was like 383 fucking horsepower or some shit like that. So, and a very good power stroke, so down cycle and a very good upcycle. So for exhaust, which doesn't actually give me anything other than an exchange of pressure. And so as it rushes out, it's like, well, there's a slight vacuum up there. And it's like, no, 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 there's a vacuum up there. But it's like, yeah, no, but it's also helping push you up. And then same thing for the nitrogen. It's like, well, there's a vacuum. And then it's like, no, 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 there's not. There's straight compression. And then it's like, right, I'm going to capture that energy during a power stroke. And then the exhaust is another version of that. So it's like I always get like effectively more work out of my turbine part for the turbo than people would probably expect. But yeah, no, it was like a little tiny engine that could, it's like this is just like some aluminum, sheet, which isn't really aluminum sheet. It's really just thicker aluminum foil that I had some fiberglass and some silicone and graphite paste that I would put into a pressure form with a. Oh no, I tried fiberglass first, but then it was like, actually just like fucking higher temperature plastic is just fine. And I punch a bunch of holes in the aluminum foil, and with the paste, it basically binds with the plastic as I pressure form it and then heat it up. So it's like heat and pressure, and then I let it cool off, and then what do you know? It's fucking great. It weighs about the same as a thicker piece of plastic, but it's stiffer and it's more heat resistant, and it flexes uh, only when it's necessary in the right areas. So it's like, oh, that's perfect for with the little tube frame that I had. That was like, oh yeah, no, I have my radiator there, and then I have my air to air chonka boys, and then my water to air chonka boys, and then like the two 140s, and then like air would just go through as per normal, and it's more than good enough because it's air cooled and then gas cooled, and then if I ever needed that during when I because even though it's balanced to a very high degree, it's like I just didn't want to take it to that much. It's like I don't need that much horsepower. I have a fuck ton of torque. This is stupid, actually. And I got a motorcycle engine, transmission, right? But this is like a standard kind of clutch sort of setup that I eventually like figured out how to machine my own vacuum clutch thing. But then that would be another version of like, remember differentials? So it's like this would be this angle, and I wanted a soft tail, so I had a soft tail. But it was like that would then have an axle directly to this differential that would allow for independent movement, like independent movement suspension rear axles. So it was like that would allow me to move that around for the rear wheel and still have like full soft tail, and it would be a hollow axle that was able to move and still be able to give me torque vectoring. So I had torque vectoring, so that way I wouldn't die having like huge amounts of torque suddenly make it impossible for me to actually ride my damn motorcycle. Yeah. Instead, I would launch with this cool suspension idea I had, where I'd pivot it from the rear, trying to lock it up to like where the front is. So like all that front or rear weight would go towards the front, and then it would pull the front down. And I had this front like so fluid and gas and a vacuum. So it's like in the hollow tubes of the frame. And so what it meant was like as it squatted and tried to load up, and rotate like that, it would then pull the front down instead, and then it would lock up and pull the rear down, and then as it pivoted during that, it then would put most of the weight in the front as it would use the rear wheel to get me going forward. So it would still be able to launch with that. It's basically a traction control with suspension to help not die. And so I could launch like a ridiculous motherfucker way too fast for most people. And it was super fun for me because I could drop at such a high RPM because I'm super balanced on that engine and had very low parasitic loss, basically almost none, almost, right? Right. And so it's like super fun, very low friction, very high degrees of cooling, machine accuracy, great compression, I had more than enough psi sent to my air fuel rail manifold, and then higher oxygen content air for it to run a much higher pressure setup at higher degrees of volumetric flow from those air injectors as they'll pump constantly, into it as it would go down for its power stroke, which would only stop its power stroke kind of like at that 3/4 eighth of a way down, and then it would go, and then it would, and then it'd start up again, and that'd be when that like exhaust would happen. And I was able to build a 2-stroke version instead of having it go up and down with the 3 ring valve thing, oil pressure helping it move down along with the gear. You know, it would then be able to like do a 2-stroke cycle, as I would have a little bit of that exhaust still in the cylinder helping, but I'd cooled off with fuel and a little bit of air. But then like I didn't really want to do it because I had a 4-stroke that had a ridiculous foot poundage. Like, so it was like, at 250 I was already at like 50 foot-pounds of torque, for an idle, right? And so I was like, well, I could go even higher. I was like, I don't need it. 50 foot-pounds of torque on a light ass fucking tube frame chassis, uh, radiator setup, all this stuff. It's like, god damn, it was like ridiculous in terms of its outright torque and power, horsepower. It just didn't make sense, especially when it's a single cylinder that's fully balanced like it is, and then it has an offset for the crank, and then like, for what it's worth, it looks like a penis with the turbo off to one side, and then a crankshaft with the crankcase off to the other side, and it's just a single shaft going up and down. Even with the fins and everything in the heads. But that was just a fuel pump from a 15-gallon tank I made, well, kind of, and basically I did run a 15-gallon tank, but it came from an old engine. But it was just like, right, and then I tried to make it with this huge windscreen and all this other stuff to help with, like, I want to lean back and with the arms. So I made a cruiser, and then I had like the second like seat, have the kind of the same thing, but I would be a little further forward because it's such a tiny little engine. I could actually shove myself right there down low, kind of almost. Well, we're in the 12 o'clock position of the tires are, which is a 26-inch rim, but then I had 3-inch tire and 5-inch width. So 3-inch sidewall, 5-inch width, front and rear, because it looks cool. And then a fender and all this other air stuff to help with, like, pulling air into the radiator and air intake and all that. But then also like double caliper, dual front and rear disc brakes. So 3-piston, double caliper, you know, dual. So it's like that was 24 pistons technically total in the front, and then 16 in the rear because they're dual, right? So 2 and 2 equals 4 total, really, but it's like 3 and 3, right? And so, like, that kind of thing. But it was like totally necessary considering it's a ridiculous over the top single cylinder engine. Makes no sense, really. But then it's like, no, that does actually make sense considering the amount of traction that you were going to want, and the amount of like ridiculous fucking. Remember the panels I was talking about? I was like, well, I'm going to make a bunch of those around it. And they have this little bar that's on the windscreen with these little rounded, but they're very necessary little wave guides at the tips of the windscreen, or the edge, really. That way it forms around, and I actually sit underneath the windscreen, and then like this big front end would allow for it to, push a lot more of that air around me and the passenger into the exhaust area, which was a muffler to a high flow resonator glass pack to another type of muffler tip that would then scoop in air from where the engine was and the sides were up into around where that muffler glass pack, the exhaust, tube is, that had a bunch of heatsink fins on it and like mounting points that would then fire through like these little spots that would go out, but it's like a bunch of reeds in that tip, and then it would have like chambers where they combine some destructive interference for like very high, shrieky sounds, and then the glass pack and high flow resonator. It's two different things, or same category but two different things. Would have like its front wrapped back into the muffler area of sides. That's a flat muffler instead of a circle. It's a flat muffler from a car that would go in from the sides and then take it from the exhaust with like the teardrop thing I was talking about, and then like that helped with resonant and destructive interference, and so it go into a big roar that was a lot less breathy, but still had some breath and turbine whine, and sounds really great. And then the air would go through these little holes along the sides, and then in the center of the little muffler tip thing, that would go from a 45 angle to an over 45 angle. So it's a right angle, well, curved right angle. That would then be like a mushroom tip is like a hemisphere, but it's an elongated oval mushroom tip that would allow for air to go around, but also through the center and a couple other places, as this exhaust would also come out through that, and in the in-between areas, and it would combine with the air that's there. So it'd cool off. And I had the aluminum plate that I did a little extra work with a bolt system and like this refractory, heat insulating stuff, and then like a little vacuum for that refractory area. And then that would be my engine. So I'd mount it from the top, and then off to the side where the crankcase is. And then like the heat shield would be another mount actually to the tube frame. And then I had like the motorcycle transmission, and then that would go off to like the axle from the top. So it's like in order to mount it at the top to go downwards to where like the pivot area for the differential is for the bike's soft tail suspension here. I had to do that to make that work. So I had my torque vector sort of set up for that too, um, in that area, right? And I have the brakes and all that, and the fenders, and so all that worked pretty darn well. And I could cruise around really well. It's fairly lightweight considering the engine, but I wanted to get like better composites and all this other stuff, and I ended up eventually figuring out way better composite materials that I'd love to talk about. But I just wanted to talk about the new, aluminum, magnesium, silicon carbide combo and formation of it, because it's like this piston head's really good. It weighs like next to nothing. It's only an inch length of stroke to bore size, but I have a huge crank, for what it's worth. But it's like it's not as big as you would expect for what it is, you know. But then it's like, right, but it's a tiny little engine. Anyways, the second passenger actually sits basically right where the top of the piston head, or the passenger, not the driver, of the motorcycle. So it's like that sits right where the head of the engine is, which is like that's where all the air comes around, the nice little teardrop. It's like constantly fed cold air, but kind of not. You know what I mean? Because it's for the radiator, but it's like it's good enough to cool it. You know what I mean? So like I almost never run it unless I'm like really at those higher RPMs where the thermocouple finally activates, and like the pump for the coolant pump will actually do its thing. Instead, it just sort of rotates it through like tubes instead back into the interior of the engine coolant, because it's a closed top and bottom head. And then it has 5 points of mounting to the cylinder, you know, like a crankshaft, and then it doesn't move like at all, right? Because it's just a really good engine that weighs like nothing comparatively to something that would have to actually have a bunch of shit to it, like a 4-cylinder big block to make like a 1.2 liter work, that like has so much extra friction versus me and way less balancing than I do. Effectively, I smoked all of the competition. I ruined their whole idea and concept of them being good at doing their job. That kind of thing. It was fun though. Like genuinely, I had a lot of fun making it. It worked ridiculously well. But eventually, I was like, "Oh, I'll make everything because I'll sell it like as an actual vehicle." People would probably like, "This is just a prototype." So I was like, "Well, it first came with just two injectors. I eventually got that to three, and so I was like, well, I'll now make like the aluminum everything, you know." And so weighs even less, has even less friction, has better tolerances, better all the things better. Put more fuel into it. I was fuel limited and never really wanted to go above 9,000 anyways. I'll put even more pressure into it. I'll put even more air into it. I'll put even more. And so I did, and it was like, well, over fucking 500 horsepower is stupid. Especially when it's like, well, now I have over 500 foot-pounds of torque, up to 28K, if I really want to. And it weighs like next to nothing. Like literally, I was able to thin out everything, make it all like a one. So it's one piece construction, literally. For engine block with the cool, um, uh, heatsink fins and engine coolant and then all the oil going everywhere and all that. So it's really lightweight. It's insanely lightweight. To put it in context, my like a comparable 1.2 liter made out of iron, that'd be the same size, shape, all that, or even steel, would weigh like about 80-ish pounds, close to that, right? Fluid in it, all that, right? Then this was like less than 40, we're about 39. And then the aluminum for the prototype, the aluminum weighed less than 30. We were around that 25, 26 pounds. And it cools much more rapidly. Right. So I was also able to push way higher pressures and fuels. And so I was like, well, a little thicker here, a little, and everything was good to go. Cylinder pressures were fine, head pressures fine, everything fine for heat too. I never had a problem, and then I could two-stroke it, and so the two-stroke version was like a ridiculous fucking monster of an engine, where like over 1,000 horsepower was easy, like 3,000 was really where I was at for that top end, pushing the near 32 K. Well, I was over 32,000 RPM with like ridiculous foot-pounds of torque that I would then have to drop off if as I went higher and higher in RPM, so that way I didn't have problems. But I was able to put all the way up to 7,000 at the very real bottom dead center of PSI. Brake mean effective pressures are really high, but then I cool them off so significantly for like my production version that it was fine. It was 55 dB, low frequency baritones with roaring, going on for like the turbine roar, and then the single cylinder is actually more like a double because of the nitrogen I'm pushing through, and then the extra air of that nitrogen through that. So it's like always a roar that sounds very much like a kind of screamer big bang thing going on. Sounds beautiful, truthfully. It was pretty easy to do. And so I sold it around 9K with the composites that I built. So it was like, if I use like basic fiberglass glass weaving, so it's like center and like there's a tube, like a Chinese finger trap thing, and then like an outside, I had 5 weaves, you know, cross and diagonal weave. Like that one wasn't really hard to like manufacture, considering like I have the ability to just sort of mill some stuff and get some threads and so on. So it's like fiberglass was easy enough to find, and then like the silicon, high temperature silicone paste, the graphite paste, and then I put in steel dust, hardened steel dust, right? And so I would heat it up with an induction over at the front, and I'd have this tube within a tube. So the tube was supported at the front, and then it would be forced in kind of like a scramjet as it would be woven together, except not really. Like it's like held in at the tube area at the front, but it would be forced in instead of having stators. I'd have it squeezed, heated up, pressurized, and then I would yank it with these rollers at the end, which would put in these little waves as it would be like gear teeth. And so like the inside would get waves to the outside, and so it would make it thin and structurally very strong and weigh very little. It was stronger than carbon fiber, forged and tempered and thinner, and so it's stronger, lighter, better than carbon fiber as a composite that I made all my tubes out of. And so like I can make him have like the little smooth part in the center for my vacuum like diaphragm and fluid stuff that I'd use for my suspension inside the tube, instead of having to have it on the outside. Then I'd have a bladder system of epoxied canvas layered with a aluminum foil that was thick enough. And then I'd pressurize that for the vacuum area versus like the fluid. So there's a fluid that, how shocks work. Like there's like small little holes in the shocks for the fluid. And then I have a spring, vacuum spring, and pressure spring around the tube. And like with the pivoting system and everything, it weighed like next to nothing. So it was like really easy to make that composite material. And then same thing with the little panels. It was another version of aluminum foil, some plastic, formed, and it was more than strong enough where I needed it to be. So it weighs like basically nothing. I'm well and truly under really. For everything, for the engine, fuel, coolant, all that, for like the motorcycle I was talking about with the wheels as well. 100 pounds total, like quite well under, truthfully. Especially since I was able to make my own wheels the same way. The rims, and then same thing for the yoke, suspension area, and all of it. It was really pretty simple when I can make it out of the aluminum stuff, but then it's like, right, I don't need it to be very strong in some of those aluminum areas. Like I don't need it to be that strong and that hard, or, you know what I mean? So as I can make it out of lighter material, it's more than good enough, you know? And so like everything was like super lightweight, and this fucker weighs like nothing. You could just move it around and pick it up with your own damn hands, and it could go over 500 horsepower easily. And it had like, the torque vector and traction control. So really what I ended up having actually happen was a lot of people bought it, but then a lot of people ended up dying because they would launch themselves on regular streets and think that they could like genuinely hold themselves for that distance. And I'm like, I don't think you really realize how close that is. When you can launch from 0 to 100 in less than a fucking second, miles per hour, from this vehicle, I don't think you get that you're not probably going to handle that the way you think. You're going to smash into walls. So we would give them this, whole spiel about don't do that, and they would still do it. I basically beat most top fuel drag racers. It would always be coming with like this ethanol and nitromethane from organic waste and fecal matter, like little bioreactor that would create like ethanols, which is bioreacting means fungus and some bacteria first with a little pressure, and then nitromethane from the nitrogen rich hydrocarbon kind of area that you just created isn't super hard. And so I had two jerry cans in the rear that are 10 and 10 gallon, and then it's a 15-gallon tank. And so we would tell people to put in for the 10-gallon, 1 gallon ethanol for each one, and then half gallon of nitromethane, which is pure nitromethane. I should specify that. Which I didn't need that to go that fast, but like you could push even further if you wanted to. 700 plus, horsepower was fairly easy, but it was like you don't need that. Like honestly, 30 to 50 horsepower is fucking ridiculous for your first vehicle. Like legitimately, I don't think people realized how dangerous the vehicle that I was selling to them for only 9K really was. It's supposed to be just a really high efficient little, cruiser to go around and enjoy like basic kind of stuff, right? It's like it's a nice soft like ride that you can lean back on. You got these little armrests. It's got this suspension seat that's got like this canvas layered in between, so bottom and top, and then they have this little nylon rope that's like across and diagonal woven with like the canvas in between, and it's epoxy. It's a epoxy canvas, and then like I have the suspension, the vacuum suspension, spring tension, and then pressure in between this plate. So like there's a plate there, and then I put a spongiform kind of material there that's got a pressure in it, and then that would be supportive of like the canvas and suspension netting that would have like that sort of stay there along with like a standard memory kind of foam-ish with a uh, veggie leather, top. They have protein, which they call it protein leather, but it's veggie leather effectively. And like that would be what you sat on, and it had a back and a nice little headrest, and then like all these nice little air things that would help push air around you with like an AC that I added to it because it's comfort. It's about comfort. And then I have like Bluetooth and then a nice little speaker setup that would send speaker sound to you. Right. Yeah, it had this nice little belt, and I have this like cool airbag sort of set up for the passenger and also you. So it's like if you do get hit, it's supposed to be able to help like reduce your chance of dying effectively. Like what it is because you're sitting pretty low into where the gas tank kind of is, towards that front, and nice little like these little prongs that move forward, like little like a fork kind of thing. But then it's like the wheel can turn pretty hard. And I had these nice little teardrop covers for my calipers, but it's like actually for the whole disc brake, and it has a circle back, and then like the teardrop shape for the front as an aerodynamic piece, and the fender would skip off and around that, but then like it would draw in some air, but then the disc brake could turn pretty far in that. So like it would still get cooled and still be able to brake just fine. And then I had a nice little filter for behind so like air would get forced in like a ram air for the fork area and suspension area, and it would kind of always create a teardrop into where the radiator area is. But then along the bottom and sides, because like the fender is there, but I don't want the nasty dust and all that getting in to my engine bay, so that I'd have this little filter there that would take in air, and then like these small tiny little diffusers at the bottom, and then underneath the driver there would be the battery and all the rest of the electrical components that's necessary for this to work, like the ECU, right? Because I ran this as an ECU. This would be like an Adreno with a couple of Raspberry Pis with open source software to talk, and then they already have like ECU open source software. Same thing with the open source software for the middle, for moving it side to side and then having everything work and talk and move the electric motors that would then make everything run properly. So all of it was that, so that way I could then sell this to people for 9K. And even the rear would have the same nice little teardrop with the fender. It'd cover most of it though. And then like the rear part has nice little backing. So it's like it's got a plate and then it's a vacuum plate between the plate that's actually, so it's like there's two plates. Well, three really. So it's like there's a plate, but that's a very fairly thin plate, and then that has a vacuum between that plate and the plate below it that's strung between the two, tube frame parts for where the exhaust is. And then I have like the pressure area above that plate, which is another vacuum between that middle plate and the top plate for the pressure area where you sit down at. So it's like you're cradled in between the two wheels, right? Kind of like you sit below, but like the person who's in the passenger basically has that right where your taint if you're a man, or your vagina if you're a woman would be, you know. So like there's that. You have a fuel rail and all that. So, but it's all able to be taken apart really well and easily and quickly be maintained and serviced. Even for fuel, like that's easy, but that was like a digital, like this is how many liters or gallons total that you have. And then because it's 55 dB and it's not hot enough for it to ultimately break and burn, like, like make nitric oxide. This is first less to begin with because there's a nitrogen filter. And then it's a very controlled burn inside of the cylinder. And then afterwards, like I'm cooling off that exhaust tremendously. And then I was like, well, I want to make sure that it's not super loud, but it has a great throaty baritone roar that would like kind of you'd feel it from far away. Of course, it's angled up a little bit off to the sides and towards the rear. Nothing's really towards the front, you know. So it's like really, really safe in terms of that side. Like all of it's fairly compact, but then like I'm a tall guy. I'm 6'4", so it's just like, yeah, no, I'm not gonna build this for people that are like super short. It's built for people my size. So it's like that engine bay, all this other stuff, very compact, but then it's like, right, but I have everything where I need. I'm sitting cradled pretty well, and then, I've got the nice little airbag and seatbelt stuff, and I got the little headrest, and it's really just meant to like be able to be nice to just cruise around. But people would go with my engine in this motorcycle, and I'd be like, I don't think you understand how low weight this really is, and like how fast you can really go. Like I got sub 2 second quarter miles pretty consistently when I would push it, because it's just a up up or down down kind of transmission. Like there's no like, oh, I get the and I have a clutch. It's like dun 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 dun, dun, that kind of thing. So you could really go fast with it, and I have to get bigger gears because like it has the torque and power for it. So I just tended to leave people alone on that side. It's like it's not the vehicle that's dangerous; it's the stupid dumbasses riding the vehicle that are dangerous. That's really what the problem turned into. It sounds great, rides like a fucking dream, like you feel yourself in the road, like you've got all the control that you want, and like you've got great traction the entire way through, great power band constantly. It can easily go way higher than it needs to go, which was like the main danger. Because it's like, well, that's an ECU thing that you can change, but then the moment you do that, it's like, hey, 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 big warning. You go through 3 warnings. It has to verbally, you have to definitely read, because it'll go through the verbal warning while it's highlighting in yellow and saying out loud the warning, and you can't skip it. If you try and skip it, the ECU gets effectively factory reset. And then like that's after it's like, are you sure you know what you're doing? And it's like, all right, so this is a thing, and it's like, we have no liability. Warning, literally nothing. This is on you. If you fuck it up, it's your fault. Get sued or something. Not our fault. Get out of here. This is essentially screw you. No. But it's a very high efficiency engine. For what it's worth, it's an insanely high efficiency engine because it weighs very little. It has the super turbo setup thing, right? And like it gets pre-run, broken in, like it barely ever has any creep. Like you'd be melting the thing if you were getting towards that creep factor. It has all the stuff that's necessary to make sure that the engine's cold and super compliant with everything that you can really kind of have it compliant with. It does look a little bit like a penis, I get that. But that's, sort of what it is. As a fairly low idle. And it sounds really nice because it can go really high up to a very high RPM. And instead of like sounding like a ridiculous, engine, it sounds really nice, pleasant, not too loud, and the exhaust isn't something that you would be scared to be anywhere near as it's cooled off. You know what I mean? That kind of whole system and setup works really, really well. And it looked really cool. It looked like a cruiser, cafe racer sort of sport bike together, with how I had to like position everything and have that tail there and have the soft tail and all that. So it looked really, really good. I liked it. And it was selling really well for what it's worth. But then it was also like, I have like the one single stroke Fiat 500 Abarth. No, you don't. You have my engine in there. That's an engine swap. It's like 25 pounds for like a ridiculous amount of horsepower and torque, right? And it's like, it's not a ridiculous amount, but it is a fairly damn fucking high amount of horsepower and torque that just doesn't make much sense for most people to really kind of use, except outside of me. Do that to get the right of the get this stuff to re-rinse this. Yeah. I have to go pee, so I'll pause this so people don't have to hear me pee for this one. Alright, so it's a very high efficiency engine. I was in the 70% range to like, mostly for sure is over 50% no matter what. But like, cold starts were a bit rough, which was like kind of the idle thing. So it's like I would do short duration pulse. And basically it's a very lean mix to try and really increase the amount of heat that I would get out of that, and then that would help out with cold starts during idle. And also I would effectively try and burn more air and fuel to try and get that to go into the exhaust cycle that would then be able to go into the turbo turbine. So like everything would run like that for a little bit to kind of get everything warm and then get everything spinning. And then since it's a motorcycle, I didn't really have to worry about catalytic conversion. But like turns out I had a better emission standard and test than like every vehicle I went up against. Especially when it's like, well, here's a nitromethane ethanol bio thing, reactor. And it was like, oh, it's basically a distillery, but then it's like, oh, here's some of the rest of it for the chemical. It's really just bacteria and some chemical processes with electricity and some heat pressure for the leftover remaining that came from that ethanol. And then after that, I'd filter out, uh, some of the salt and whatnot, and then I'd mix it as a nitromethane ethanol blend as a 1.5 gallon mix each time when you fill it up properly. And then out would come fertilizer that you could use with a little bit of that salt and some other mineral content that would be separate. So, and then it had like, oh, you can make a battery, a sodium ion battery if you wanted to, because it would still have some carbon. And so if you wanted to run it, it would still take some of that carbon and make a little, setup to eventually make a full on, depending on the size you were looking for, to its max size, sodium ion battery. But like you got that for 9K. I was originally going to sell it for like 30, but it was like, oh, probably, I mean, a brand new player, all this stuff. So I was like, I'm probably never going to be able to have anyone buy this for $30,000. Instead, I was like, man, I'll probably be able to get people to trust me at 9K. Like if it's a bad thing, then like, oh, I only lost that. I sold so many. Like seriously, just so many. And then I made like a kind of Ducati-ish looking sports bike, concept where you have to lean really far forward, like super far, like you're leaning onto the tank, and if your arm or your legs like tucked into the bike with the shrouds around it to help with like all this airflow around you. It had a nice, no passengers, so it's just a one person bike, but it didn't really matter because it was like, yeah, it has the this saddlebag area, and then like an extra area for putting any groceries or something in it, and then the engine wind or the windscreen, not the engine, the windscreen would be fine and go over you. It had this mirror set up so that way you could look down, and then it had this like double mirror so you'd see forward. It was a pretty decent view. I still had mirrors on like the original bike too for the side mirrors and like a little top mirror thing too for the windscreen, but then I was like, no, just look forward. Just look forward. Just stop being weird. Just look forward. A little more cooling, a little bit more of that, and they had a slightly higher uh, horsepower and torque, but then it was mostly just the lower weight of the whole thing. And that one sold ridiculously well too, but it's built for like people that are my size, 6'4", slightly more up to about that 7 foot range, and then like down to maybe like you were 5'7" at most, because I had like this seat thing that would change, so it's like it would change where your seating position was and where the feet rests were. Nothing was done with foot clutches or anything. Everything was just like moving like a button or whatever. I had this literal trigger. So you know how a dual action revolver works? Like pull it and then boom, right? Like that'd be the clutch trigger if you wanted it to like get that, and it'd stick around for a little bit, and then you'd have to hit the button. I hated foot clutches. I don't know why I hate foot clutches, but I did for some reason, and so I just never put them on anything. And like instead of the teardrop, well, it does look like a teardrop for the fender, the front fender, and everything, but it looks like everything aerodynamically was to make a very good teardrop up into where the exhaust would be, and so it would capture a lot of that exhaust, where the air is coming in and out, and sort of like try and make a lot less sound, so it wouldn't be so ridiculous. you know, Not that you needed it. An idle full chat 9K is still 55 dB coming out, big throaty roar thing. But it was like, you're really not going to hear it now when you're going. unless you're like right behind the person, in which case you'll probably hear them. But yeah, no, like that one sold pretty well for what it was worth, and I was making good money because it's really cheap to make the composites. Like it was extraordinarily cheap to like make the things do that. They were weldable too, which is great. You know that steel thing that I was talking about, the silicon graphite paste with the aluminum, or not the aluminum, the fiberglass, right? Like turns out when you do that and you use a little bit of electricity, like you can just weld the whole thing. Like put a little argon around it, like place like an electrode, like a little circle, and then it would with this microwave setup and then like electricity, it would basically weld the full thing together. And so like this piece to this piece, you know, like two rings or half rings or even like four of that would then weld the whole thing together, like inner diameter area to all the way to the outside as a total one piece construction. They were easy enough to build, to bend and build. And so it's just like jig, automate it, here. Even with like the gas tank, it was another version of like, oh well, I'll just like make the panel, you know, thing, and then I'll just put in some fucking like stainless steel. You know, that's literally it was pressure formed stainless steel with the panels anyways. And then it's like weld, like real simple stuff, super fast, worked all the time. I never really had to worry about anybody. Like, what's the engine oil? It's like standard engine oil that I could easily buy at any fucking like store. It's like nothing special there. Same thing with engine coolant. And then it was like, right, so then how often do you service it? Like, I haven't changed my prototype out for the oil or anything for what it's worth. Like, it literally burned so little oil and it never got hot enough that I ever had to worry. Because I also have an oil. I forgot about that. I had an oil cooler behind the engine's radiator. I had a little oil cooler, so it just never got hot enough for me to worry. You know, like I just constantly replaced it into like because I have to always pump oil as like the balancer. You know what I mean? It's a harmonic balancer and a fucking suspension balancer for a counterweight. So it's just never had to care. But it's like whenever 10K, 5K, whatever the fuck it says. I don't know. Just do it. I literally, I never gave a shit. I legitimately never gave a shit about the oil. It's just like transmission fluid, on the other hand, I gave a shit about constantly. People would fuck up that transmission so often. I was just like, what are you doing? And I had the aluminum, you know, but it has a fatigue limit, by the way. Like that compound, like that material has a fatigue limit. So it'd be pre-fatigue limit, and then it was like a bitch to fucking mill that fucker. Like that polycrystalline diamond from those fuckers saved me so much money. Oh my god, I would have gone through so much money trying to get this thing milled, and eventually I started making my own bits from this shit, and then try and make it a little harder, you know, and that finally got me somewhere, you know, in terms of saving my shit. Like, especially when the crank is made of, like everything was hollow shit too. Like everything is like the crank is hollow, like for real, like super hollow. But then it has like, you know, I had to do it for the original crank anyways for the prototype, but it was like I need oil to go through and into the bearings and everything else, and same thing with like the connecting the wrist elbow, you know, rod, right? The double elbow rod connection, and they're like Atkins cycles. I'm like, well, I don't know what the fuck that is, but point is, it's up and down. Never gave a shit about any of that. But it's like, it worked out for what it was worth, like extraordinarily well. But it was like, oh, yeah, I can easily just form mold like fuck tons of this stuff. That being said, there's not a huge market for motorcycles, so eventually I had to go like, all right, fine. They want piston engines for cars now. I don't wanna. Here's the fucking toroidal engine that I wanted to make finally. With the inner burn combustion zone, and then the outer ring, and then outer ring for my kind of like exhaust recapture performance. With the thermal photovoltaic and thermoelectric generating stuff and all the rest of it. So it's just like, well, I want to get a high efficiency, over 90% efficiency engine. I'm going to need to do this. So it's like, fuck this. And so I started making my own, like, well, it's, tube stuff, and then like panel, and then like vacuum area, and then like this is tension stuff. And it's got a hidden roll cage, and like suspension, suspension bridges. They get bigger because like they're supported better, right? Same thing, same concept, effectively. I just did that essentially with the tube frame and panels and so on, and I welded everything together. It weighs way less than an average vehicle. The axles were super fun. I made a bunch of vacuum axle stuff that was super fun to make. It weighs like nothing. I had like all my axles turned into like these rifled uh, little aluminum alloy, aluminum alloy silicon. So aluminum, magnesium, silicon composite, alloy stuff that's like weighs next to nothing. It really doesn't weigh much at all. It's stupid. Then it's like rifling it, and it's like, fuck that. I'll just pre-rifle it in the damn mold. And the arm was able to get smaller. Everything was able to get much smaller, much faster, because the materials were way stronger and lighter than it was before. And so it's like, super. This is great. And a big old monster truck of a fucking vehicle weighs about the same as a, like, larger sedan, 4-door sedan. I started selling buses and vans with cool windows, and some dude wanted a fucking truck. I was like, all right, well, if you're willing to pay for everything to make the truck, I'll fucking start selling trucks. So I was starting to just get bored of it all, as I started making a bunch of hybrids, and my electrostatic and like a regular repulsive electromagnetic motor. So it's attractive electrostatic, but then attractive electromagnetic things to the electrostatic, and then it's standard electromagnetic repulsive motor kind of thing that would use all my cool like kinetic and momentum or mass amplification stuff. It's mass amplification. It's like a bunch of cool words, but it's like an eddy current that for a temporary amount of time means it resists going backwards, and it sends that backwards opposing repulse back into the attractive force. So it's like, and then it fires forward a given material, whole thing, as a mass that then catches up to that, and it does it again, and does again, and does again, and does again, and does again, does again, does again, does again. It's all timed very, very well. So I just never really have to worry about it. But it was like, oh, look at my sodium ion and like this cool field effect. And then like, so static charge, like capacitors. So it's like capacitors, piezoelectrics around there. But then it's like, if they have a sodium ion with the correct field effect capacitor, and then capacitor, static charge field, then it would then try and have to do a lot more work energy during that. It would create like a heat and then cooling effect for the piezoelectrics, but then also like the electrons were during its movement would go through a field that would kind of like how light would split and entangle itself, for a quantum slot experiment or whatever. It's like I was able to do that with electrons, and then with the given field as it would resist or be attracted, kind of thing, I would then be able to go and make multiple extra electrons for the given conversion heat entangle thing that would separate its entanglement during that. And so I got way greater amounts of battery capacity for the given uh, size and weight that they were before. Start putting them in all my vehicles, and I had like 5,000-mile ranges from the hybrids that I had that had very little actual like nitrogen oxide, or and then I would have a carbon capture from the battery as a way to help with like um, the fuel cell area that I ended up creating from so like if the battery has these static charge and then the exhaust is going through and as a piezoelectric, it then means I can separate that and that creates an electron flow, for the given electricity, and I then can cool it with piezoelectric, helping that along to be able to create heating and stressing. So it's like that together with the waste heat generator for cooling the engine meant I had from that given heat energy created more electricity than I had before, and it would capture the carbon into a can, and then I would fire it into the engine, and over enough time it would eventually burn all the carbon, but it meant I had a much greater fuel range extension than before. And if you wanted to, like, oh, the carbon can was full, then like you could drop that off and get points or whatever with us, as we had a little program because we'd use that carbon to help with our graphite paste and so on. So for the given fuel, it was like, oh, give us that, and like here you go. You know, well, a points system is a good way to be like, hey, this is repair or maintenance or whatever the fuck you want, for fuel as well. Because it's like, well, you're going to expend the energy anyway. So it's like, that'll be our carbon and you'll have the energy. And so I don't really have to care. Solar panels galore, made up with graphite and some field effect transistor stuff with like constructive and destructive. So like through a quantum slot experiment, destruction for IR energy or light would then be able to be constructively interfered in such a way that it'd give me a higher frequency light for a little bit of loss, sure, but then like I need that light for the light capture in the silicon solar panels that would then give me a better efficiency than a standard silicon solar panel would. They were like all over the hood and roof and trunk of all my cars. So that way I'd be able to like, get more range extension effectively. For what it's worth, most people almost never really needed to refill their batteries because they trickle charge on their own from the air around us, and I used like the little electricity field thing to rip off the oxygen or rip apart carbon dioxide or nitric oxides, and during that it would recombine into nitrogens, H2Os, or just carbon capture with oxygen freed as a generator kind of style. Not to mention the solar panels also help with the whole thing. So any humidity in the air would have a charge field difference. Basically, most people almost never needed actual fuel to run their car. They only really, I had it there just as in case you needed to really go a really far distance. So I ended up making a good damn amount of money, and then I sort of just quit as I made a bunch of rocket engines and flew away. I'm not even kidding. I was like, I'm not coming back. If this fucking flat faster than light travel thing works, I'm not coming back. And then it worked, and I never came back. I left, and nobody heard from me again, and I was fine with that. Meanwhile, I was like, well, I shut down all of my stuff, and then I dismantled it into basically a bunch of parts that were just raw components, and I deleted all my files for all the stuff everywhere, and then I flew off in the rocket. And if I came back down, I'd be able to like get it all back up. But then nobody had any information, and I left. So like that was fun. Really, yeah, the last transmission I ever had from those fuckers before I turned off the little faster and light, like little, quantum tunnel, communication to the internet was like, "Can you guys please come back?" And we said no, and then we sent out the little key to fully delete and zero out everything. We sent all the money off to a bunch of people that needed it and things that needed it, and I just never fucking cared. So. Like, you are the lizard devil tongue. Meanwhile, me, yeah, I'm good. I refuse you in all aspects. You're a dumbass retard that thinks that you know things about me being a devil or some shit in disguise of something. That's basically all I ever did with that. It's a fun whole little thing for what it was worth. It was a pleasant little ride too. Most people really didn't maybe understand where I came from on like why I made the engine in the first place. I was like, because it's efficient and it's a really cool little project, and then it means I can do other things later and got investment and all this other stuff, and started cooking, right along, getting my stuff done that I needed. It all started with SSI though. I can't work a job, so like there's that problem that they don't like to hear about. It never would have worked if I didn't have that time to really kind of invest in everything. So like SSI was always the case of getting somewhere, albeit slowly, but it did happen. All right, that'll be the end of that.